morning, distinguished guests, industry partners, faculty, and students. Welcome to Interface 2026, a joint academe industry failure analysis symposium.
Today marks a significant milestone as we gather to bridge the gap between academic innovation and industrial practice. The term interface represents more than just a meeting point. It is the boundary where distinct phases, academe and industry, interact to create stronger, more resilient engineering solutions.
So, to begin our program, we would like to invite everyone to stand for the singing of the Philippine National Anthem, followed by an invocation.
Mga kababayan, ang pambansang awit ng Pilipinas. Kayang magiliw, hewas ng sinakanan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, kuya ka ng magiting, sa mandulupin, di ka pasisingil, sa nagatak tutok sa simoy at sa langit ng bagaw, ay hinatang tula, kawin sa pagkayang minamahal. Ang isang ng matawad mo'y tagumpay na nagtitingin, ang bituin at araw niya kailan pa may di magtitingin. Luman ang araw ng walhating pagsinta, buhay langit sa piling mo. Ang inigaya na pagkay mga aking, ang mamatay ng dahil sa'yo.
Dear Heavenly Father, we thank you for gathering us all today in this important endeavor. We ask that you bestow your guidance and blessing upon each attendee. May we honor one another by keeping an open mind. May we voice our truth and listen with an open heart. Bless everyone present today, that each may be able to share his or her contributions and gifts. Grant good health and safety to loved ones left outside this room, and bestow peace and goodwill to all of us. We ask for your wisdom and grace to use our talents for the betterment of others. May the various activities related to this day be a success through your intervention. With gratitude, we offer this prayer in your name. Amen.
At this juncture, we would like to acknowledge the presence of our distinguished dignitaries and guests of honor who have joined us today.
We are honored to be joined by distinguished leaders, industry partners, and esteemed guests who have made today's event possible. We request that all of our guests please stand as your names are called, and we invite the audience to hold your applause until we have recognized all our guests. First, from the university and government, uh, Deputy Executive Director for R&D of DOST MIRDC, Dr. Agustin M. Fudolig, along with Senior Science Research Specialists, Engineer Chelsea May Escutin, and Engineer Joey Pangilinan.
We are also joined by our industry partners from Semirara Mining and Power Corporation, Executive Vice President, Chief Technical Officer, and Chief Commercial Operations Officer, Mr. Chris Gutschano. Senior Manager of Occupational Safety and Health, Security and Community Relations, Mr. Lamberto Dimaano. Joining them are Engineer Ansel Rom Mendoza, Engineer Mayet D. Marco, Ms. Portia Vizconde, and Mr. Vincent Tumarang.
From Steel Asia Manufacturing Corporation, Vice President Mr. Ryan John Bernabe, and Philippine Iron and Steel Institute President Mr. Joel Ronquillo.
From Pag-asa Steelworks, Engineer Edgar C. Marquez.
We also recognize our professional associations and sponsors, President of the Institute of Materials Engineering of the Philippines, Doc Eden, representing our silver sponsor, Sigmatech Incorporated, Mr. Terence Rene Igides III, and Ms. Maria Garin Endonela, and Engineer Marlon Yana.
Representing our bronze sponsor, Bihis Maala Basics, Ms. Christina Carcamo, Ms. Arlene Jean Maala, and Mr. Alan J. Biasa.
Finally, we extend a warm welcome to our special guests and key organizers. First, former Secretary of Department of Science and Technology, Academician Fortunato T. de la Peña.
Founder of MGB Consulting Incorporated, Engineer Mark G. Buado.
Chair of the Materials Engineering Certification Board and Professor at the UP Department of Mining, Metallurgical, and Materials Engineering, Dr. Leslie Joy Diaz.
UP Department of Mining, Metallurgical, and Materials Engineering Department Chair, Dr. Mitch Irene Kate G. Oyales.
Program Leader of the UP Failure Analysis Hub, Engineer Stan Christian Ehera.
Executive Director of the UP Engineering Research and Development Foundation Incorporated, Mr. Alfonso Certito Aliga Jr. Ladies and gentlemen, let us give a resounding round of applause to welcome all our distinguished guests.
To officially open our proceedings, let us welcome the UP DMME Department Chair, Dr. Mitch Irene Kate G. Oyales, for the welcome remarks.
So good morning, everyone. Thank you for introducing our guests. So let me be informal in our home department. Di ko na po iisa-isahin yung mga guests natin. But I'm really glad that all of us gathered here for this event. Okay, so ang goal lang namin talaga when we started this is to inspire our students. Kasi in our program, if some of you are not yet familiar, we are offering 3 programs, the Mining Engineering, Metallurgical Engineering, and Materials Engineering. And 2 of them, yung MET-E and MAT-E, we have a course on failure analysis. So every year, we are conducting actually yung colloquium na ginagawa namin. Our students are presenting their final output. And that is the time where we also give them the final grade of their case study. So they go with, they communicate and work with industry on a specific FA case, and they investigate it for a semester, and then their final output, talagang gagradean lang namin kami mga faculty, yung kakalabasan. So initially, our idea is let's invite industry as well to see what their output are. Tapos, since we also have parang ilang years ago, there's meron dyang packet rin din sa binigay sa inyo, din sa history ng FA Hub. So when we had some FA case na gusto rin namin na makita ng student kung gaano ka-relevant yung FA cases na hinahandle nila, that it has really a big impact to the industry. So it was just really that kind of goal. Kasi during their first year, second year, we are just building up on their knowledge with the structure, equipping them with knowledge on the characterizations of different materials and specifically for metals. Tapos, pagdating na ng fourth year, they will now culminate those ideas into this final course on failure analysis. Okay, so ganun lang talaga kasimple, but we are very lucky that there are a lot of industry who agreed and also attended today to our invitation. Okay, so hindi na lang siya ngayon simple colloquium, but we're really surprised with the vast of guests na dumating ngayon. Okay, so of course, we want to express our gratitude, special thanks to Sir Chris. Kasi it started with his trust to our department, to our team. Nag-start lang siya with a simple case hanggang sa pumasok na yung may mga donation, and it grew into let's establish a failure analysis hub in the department. His acknowledgement of our capabilities and yung pag-share niya rin sa iba-iba pong industry ng mga nagagawa rin po namin, it's really a big thing. Kasi for so many years, and some of you might also agree, na there are a lot of academic outputs that are remain in shelves. Okay, so we really need to have a movement na kailangan close to industry, lahat ng mga ginagawa namin sana talaga nakikita at nagagamit ng industry. So that is really where we stand now as a department. This kind of symposium collaboration with industry is what we really hope for, na hindi lang siya for this event but also will continuously transpire. Ito kasi din talaga yung kinakailangan ng country natin to advance whatever technologies and capabilities that we have. Sayang kung yung mga engineers na napoproduce namin, makikita ninyo yung capability ng students namin, ay kukunin lang din ng ibang bansa. So we really hope that we could retain those talents in our country. We really need the kind of appreciation that Sir Chris has given us. Same po sana with the other industries that I hope we will be able to convince you dun sa makikita ninyong outputs rin ng mga students. So I'm sure you are also very excited to hear from our guests. Okay, so kahit ako na starstruck to see former Secretary De La Peña in our auditorium, and we also have Sir Mark Badwa. Okay, so it's really exciting day for us, and I hope na hindi lang rin basta na ma-inspire yung mga students namin, but really we could really cultivate to them the impact of failure analysis. Okay, so I will no longer hold the stage, okay, so we could start our program. Again, welcome to our department.
Thank you, Doc Mitch. Our mission today is to elevate the discourse on materials engineering and failure analysis.
And to officially commence our technical discourse, we are privileged to welcome our keynote guest for the morning.
Distinguished guests, it is a profound privilege to present our keynote speaker, Academician Fortunato T. De La Peña. A visionary engineer and dedicated public servant, he led the Department of Science and Technology as its secretary from 2016 to 2022. An esteemed alumnus and former administrator here at UP Diliman, his legacy of leadership bridges the sectors of industry, academia, and global scientific cooperation. He remains a steadfast advocate for national progress, currently serving as the chairman of the Board of Trustees for De La Salle University. Please join us in welcoming Academician De La Peña as he presents his keynote address, Building and Strengthening Failure Analysis Capability in Support of Industry Development.
Salamat, magandang umaga po sa ating lahat, at ako ay natutuwa dahil sa kauna-unang pagkakataon na pasok ako dito sa audiovisual room na ito. Nagpupunta ako noon dahil sa mga research na ginagawa ng DMME, particularly yung may kinalaman sa environment-friendly gold processing. You know? Nagulat ako dahil matagal na akong hindi na imbita sa College of Engineering maliban sa mga events ng aming foundation. Kaya samantalahin ko na rin batiin ang aming long-time executive director, si Tito Aliga. Nakita niyo na si Tito Aliga. At binabati ko din si Engineer Buado. Nakita ko yung kanyang background sa Texas Instruments. May mga pagkakataong nakapagdala din ako ng mga estudyante dyan sa Baguio Economic Zone. Ano ba tawag doon? Baguio ba tawag doon? Ha? Oo. So, nung ako ay secretary, this was the years 2016 to 2022, ang inadapt kong parang pinaka-tagline ay Science for the People. At essentially, ang gusto kong mangyari ay maramdaman ng ating mga local industries, ng ating mga mamamayan, ang kagandahan na nadudulot ng science and technology. Particularly, yun nga, empowering local industries, creating economic opportunities, at saka yung public safety, public welfare and safety. Nung ako ay active pang nagtuturo, na-encounter ko lang ang failure analysis dun sa mga tawag dito, yun sa mga statistical probability distributions na pwedeng gamitin sa live testing and failure analysis. Pero hanggang computation lang naman ang ginagawa namin ng mga problems. Wala naman kami talagang laboratory na I taught at Industrial Engineering Department, by the way, for 43 years. Kahit ako nasa DOST na, nagtuturo pa rin ako. And nakita ko talaga, failure analysis embodies the philosophy of science for the people in a very practical way. In our field, industrial engineering, we do prioritize the streamlining of processes and optimizing complex systems to reduce cost and to minimize delays. In effect, yung favorite word ko talaga is productivity. We raise productivity and, of course, secure human safety. And failure analysis complements these objectives by systematically investigating how and why products, materials, equipment, or structures fail. Siguro at this point, hindi na ako nagbabati ng mga tao, pero as I go through my paper, naaalala ko kung sino yung mga nandito. Nadinig ko yung pangalan ni Engineer Ryan Bernabe. Nandito ba siya o represented lang? Wala siya. Represented. Okay, nagkamit na tayo. And Engineer Ryan Bernabe is a product of UP, this department, and he is the Vice President for Excellence of Steel Asia. So actually, I asked for some statements from Bobby Batumbakal, who is a leader in the manufacturing sector, regarding the importance of failure analysis. Sabi niya, ay katanungin ko na lang si Ryan Bernabe, mas naiintindihan niya yan. And Ryan Bernabe said that failure analysis is very important kasi nga ito yung kailangan to analyze problems that occur, to anticipate yung mga problema so that we can address them. And of course, the good news that I got from them is that they're expanding really in a big way ang Steel Asia. So makikita rin natin ang kahalagahan ng failure analysis doon sa kanilang mga gagawin. Now, the true value of failure analysis extends beyond the technical accuracy. It provides the knowledge needed to anticipate problems before they arise, enabling industries to make better decisions, improve product quality, and use resources more efficiently. In this way, failure analysis contributes not only to operational excellence, but also to economic resilience and public welfare. Sana ginagamit din natin yung failure analysis sa buhay natin. Marami na akong failures. Hindi ko yata na-analyze. Pero sa kasalukuyan nating kalagayan sa ating bansa, ay napakaraming failure analysis na kailangan gawin. This becomes especially important in the context of local manufacturing and R&D. A strong manufacturing sector depends on the ability to produce reliable, high-quality products. Ano, yan ang aming focus sa R&D, lalo na doon sa PSEARD, the Philippine Council for Industry, Energy, and Emerging Technologies, R&D. At the same time, meaningful R&D would require the capability to understand material behavior, identify weaknesses, and continuously improve designs and processes. Okay? Failure analysis serves as a bridge between manufacturing and innovation by generating the knowledge needed to develop better products, improve production systems, and build confidence in locally developed technologies. So, yun ang na-enjoy ko actually part sa trabaho ko noon sa Department of Science and Technology. Kasi binigyan ko ng importansya kung ano nangyayari sa labas ng Metro Manila. At doon ko nakita na ang daming kailangan nilang technology at mga services doon sa iba-ibang regions. At yan ang dahilan kung bakit mabagal ang progreso sa mga regions, kulang na kulang sa mga technical or technological services. And siguro banggitin ko na lang dito, when I came in, the percentage of R&D money given as grants to the different regions is very unequitable. Okay? About 80% is going to 3 regions combined. Metro Manila, Calabarzon, and Central Luzon. Alam naman natin siguro kung bakit nandyan yung mga malalaking universities, okay, in these 3 regions. And then the rest of the 13 regions were competing for the 20% remaining. And we had done some steps, and I really miss Dean Rowena Guevara, our own first Lady Dean at the UP College of Engineering, kasi pag sinabi ko lang sa kanyang ganito yung gusto kong programa, paplansyahin na niya talagang in detail. So sabi ko, gusto kong magkaroon ng programa na ang title ay Science for Change. No? And she already came up in a very short time with 4 programs supporting that Science for Change. Yung pagtatayo ng mga NEETs research centers, okay, in the regions, and we have established 42 NEETs research centers in the regions in our term between 2018 to 2022. Doon namin na-implement yung CRADLE program, which is the collaborative research, okay, to leverage the economy. And this is really sort of giving a lot of incentive to our enterprises, particularly the SMEs, to do R&D in collaboration with the research and development organizations like the universities and the R&D institutes of government. And we also had a program where we deployed our experts, yung maituturing nating national experts in the different fields, okay, who are located in different places, but of course mostly still in the urban areas, to be fielded in the different regions para matulungan nila yung mga universities in particular to start their R&D program in the area where they have already some expertise. Then we came up with the last program, yung binanggit ko na yun ang RD Lead program. And then the last one, which was not heavily utilized yet when I left, is the BIST program, or the Business Innovation Through Science and Technology. Yun yung we were providing the funds needed by our local SMEs, or kahit na hindi maliit. Well, kasama na dun yung M. Kahit malaki-laki na rin, and to acquire the facilities that they need for R&D. Okay? And yun nga, kasi nga, kokonti naman ang Philippine companies na talagang nag-R&D na. So, before I left, I think there were only 4 who have availed of the program, and all of them are in the pharmaceutical industries. Okay? Now, our condition in helping SMEs, whether it is for production, improvement, or for doing R&D, is that we advance the money to procure the needed equipment, hardware, software, so that they can already do the improvement in their production or to carry out R&D. And since we are not a government financing institution, we are trying to, of course, avoid COA observations. And so we just call it an innovation fund. Okay? We do not give ano tawag dito? It's not a loan. Okay? We actually procure, or the equipment or software are procured, okay, in the name of the that being used until they are paid. Now, the Philippines understands the importance about improving, okay, our products, more competitive. And for decades, the government has recognized the importance of developing capabilities in materials characterization and failure analysis. I tried to recall, okay, the periods when these interventions started. As early as the 1970s and 1980s, the Department of Science and Technology, through the MIRDC, or the Metals Industry Research and Development Center, began pioneering work in this area. Strengthened in 1989 through the Official Development Assistance Project with the German Agency for Technical Cooperation, MIRDC has since then served vital sectors including transportation, mining, power generation, and food processing. This was the time when Dr. Arizabal was really building up MIRDC, and the young engineers, almost the same age as kami ni Tito at that time, were sent to Germany, okay, to learn in that area. I also remember MIRDC pioneering in the area of business incubation because they have big facilities there where the SMEs, they cannot buy those big facilities, so they just locate there and utilize the facilities of MIRDC at a certain cost. Now, MIRDC continues to expand, helping both the public and private sectors diagnose critical metallurgical and structural failures. Of course, it is also quite well known now because of their advanced manufacturing center, which is focusing on additive manufacturing. So I think this June, I don't know which exact date because kung minsan, pag hindi ka na secretary, hindi ka na iniimbita. So, but I know that they are opening to the public their 3D printed houses. Okay? Hindi ko alam kung binuksan na. June is Metals and Engineering Month, and most likely this will be the time that they will introduce it to the public. I saw it already, pero ayaw nilang pakunan ng picture kasi nga ila-launch nila during this Metals and Engineering Week. As technology continues to evolve, so too must our scientific infrastructure. Because the Philippines plays a massive role in supporting the global electronics and semiconductor supply chain, our local capabilities must be world-class. I remember for a long, long time, the Department of Trade and Industry, at that time through my counterpart, the senior DTI Undersecretary Tom Aquino, was always nagging me saying, kailan baka tayo magkakaroon ng testing facility, advanced materials testing facility? Gusto kong sabihin, trabaho nyo yan sa DTI, pero siyempre, since it is a technical facility, meron din kaming responsibility. So, of course, it was not easy to get funds from DBM, and it was only later, I guess, in the early 90s na yon, when the Advanced Device and Materials Testing Laboratory at ADMATEL, hindi pala, 2012 na pala siya lumabas. This was the period when I was the Undersecretary for Scientific and Technical Services, and it is managed by the Industrial Technology Development Institute through their Material Science Division. So, equipped with state-of-the-art facilities for materials characterization and failure analysis, ADMATEL provides critical services for industries involved in semiconductors, electronics, and advanced manufacturing. I went there together my co-worker here, si Kenneth Bello, who is a graduate of DMME. And actually, we saw there a group of DMME students. I think more than 10 of them, they were visiting the facility. Okay? Hindi ko alam kung nagma-masters yun or undergraduate. Kenneth, undergraduate ba sila? Yung visit, undergraduate, okay. And nakasabay namin sila, kaya kami kami ng photo op doon sa ADMATEL. But they also, hindi naman problema, but something that maybe because of developments na rin doon sa ating mga local companies, marami na doon sa kanilang clients ang nakabili na ng sarili nilang mga testing equipment. So, nabawasan ang kanilang clients in the semiconductor industry. And so, they have to, shift their attention to the other industries that will require yung mga analysis ng ADMATEL. Of course, in the construction and infrastructure sector, merong possibility dyan, and other sectors as well na nangangailangan ng ganitong tests. Now, alam niyo nabanggit dito yung semiconductor, and hindi ko nababanggitin kung bakit ko nabasa yung mahabang, curriculum vitae ni Dr. Lito Mena. Talagang na-impress ako sa ginawa niyang R&D in the area of semiconductors na related sa materials. Of course, he is an academician. He became an academician much earlier than me, and I remember he has received all these awards: R&D, award for teaching, award for innovation, and all of these are in the semiconductors industry. And today, I have some interest in the semiconductor industry, not because I am an expert in electronics or semiconductor, but because of force of circumstances. My first cousin who established a semiconductor and electronics company, ATEC, is now 93 years old, and he said, I don't want to work anymore. Sabi ko, siyempre naman, 93, dapat nagpapahinga ka na. Kaya nga, ikaw na mag-chair ng aking company. Sabi ko, wala akong alam sa electronics at semiconductor. Sabi niya, hindi bali, basta meron namang presidente. Kasi unfortunately, his two sons died ahead of him. Sana naman mabuhay pa siya ng mahaba para patuloy siyang sumuporta sa UP Engineering Research and Development Foundation. But I heard good news that after a number of years, talagang ang market situation medyo pababa. But this last few weeks, I heard some news na merong magagandang developments. Now, these facilities, as I said, are more than just testing laboratories. They are actually national assets that support innovation, strengthen local manufacturing capabilities, and enable researchers and industries to solve increasing complex technical problems. Siguro i-report ko na rin sa inyo, isa sa mga, ano ba tawag doon? Yung talagang gustong-gusto kong mangyari sa DOST ay magkaroon ng partnership yung mga research and development institutes at universities to offer advanced degrees like master's and PhD. Nangyari yon through the Industrial Technology Development Institute at Mapua University. So gusto nilang magkaroon ng PhD program na focus sa nanotechnology. So nagpunta sila sa CHED and tinanong kung ano yung mga kailangan gawin. Sabi ng CHED, kung hihintayin nyo kami magkaroon ng mga special committees, aabutin kayo ng taon-taon. Maybe what you should do is look for an existing program na pwedeng mapaloob yung nanotechnology at mas mapapabilis ang pagbubukas nyo ng program. And we looked around. It so happened that Mapua has already an approved materials engineering or material science PhD, okay? Approved sa CHED, and ino-offer na nila. So we discussed with Mapua, nag-agree that ITDI and Mapua will collaborate, will have a partnership in offering a PhD in materials science ba o engineering? Hindi ko na matandaan, ha? Science, material science. So, meron din kasi experts sa ITDI at saka meron, of course, sa MAPUA. So, nag-agree na lahat ng research, okay, ay doon gagawin sa ITDI. So, that benefits the institute. No? So, siyempre, lahat din ng pondo manggagaling sa DOST kasi doon gagawin yung research sa isang R&D institute ng DOST. Unfortunately, wala pang sumunod na ibang R&D institute dito sa model na ito. And what I hope that meron pa rin makakasunod. Kasi maraming may potential. MIRDC, the Nutrition Institute, the Nuclear Research Institute, ASTI, may mga potential na magkaroon ng ganong program. Kaya ako na-inspired dyan, nung araw pa, bago ako bata pa ako nung pumunta sa DOST, nakita ko na yung model sa Korea na meron talagang strong collaboration, yung mga R&D institutes at saka yung mga ano tawag dito, mga universities. Okay? Actually, yung nanotechnology, maraming countries pala na hindi naman ganun kalalaki na magaling sila. At, well, if you measure it by the publications record, no? Isang interesting experience ko before I left the OST, yung ambassador ng Iran, gustong-gusto niyang pumunta sa DOST parati. Ano? Punta ng punta yon, gusto niyang magkaroon ng agreement. Ako naman, when I came in as DOST secretary, I had one policy. We will not simply sign agreements because there are countries who are approaching us. Okay? Kasi ang nangyayari nung araw, pirma ng agreement, wala namang nangyayari. So sabi ko, ilista natin kung anong mga areas sa technology ang kailangan natin ng collaboration at humanap tayo kung sino ang magiging partner. So naglista kami. Okay? Mahabang listahan din, mga around 20 areas where we want partnerships. And marami doon ay natuloy. So partnership with France, partnership with UK, partnership with other countries. And itong Iran hindi kasama sa listahan. No? So ang kulit talaga, punta ng punta. And off record ko pa ba yun? Hindi na. Okay. Punta ng punta hanggang sa isang beses kasama na niya yung kanilang Deputy Minister for Foreign Affairs. No? So nangungumbinse and sabi ko, sige, pupunta na kami sa Iran. Ang hirap maghanap ng kasama kasi ayaw nila matatakan ang passport nila sa Iran. Baka daw hindi na sila papasukin sa Amerika. So mabuti namang si Yusek Geb ay matapang. Ano? So kami ni Yusek Geb pumunta at saka si Dr. Bio ng Science Education Institute dahil may kinalaman din sa Human Resources Building. So pagdating doon namin nakita na there are a few areas na interesting. Number one, Iran has a Vice President for Science. Okay? Pangalawa, the professors are allowed to do business. If they want to commercialize, habang nagtuturo sila, hindi kailangang mag-leave. Okay? Nakakatayo sila ng kanilang mga small enterprises. Pangatlo, nakaka-produce sila ng mabilis ng mga translation ng kanilang R&D into something that can be marketed. Ang pinaka-interesting sa akin doon, wala na yatang kinalaman sa failure analysis, pero ito ay may kinalaman sa testing ng mga research animals. Ano? Dinala kami doon sa kanilang laboratory na para siyang complete laboratory para sa tao. May X-ray, may MRI, lahat. Pero maliit lahat. Yung pala ay para sa mga daga. Ano? Sabi ko, magkano yan? Gusto kong bumili niyan para sa Pilipinas. Sabi, tingnan kwenta namin, 5 million pesos, magkakaroon ka na ng isang buong facility like that for research animals. Ayun lang, problema pala, hindi tayo makakabili sa kanila kasi may embargo. No? Hindi tayo pwedeng mag-deal ng business sa kanila. Okay? So if you want to buy their products, you have to buy it from China. Okay? Anyway, masyado akong chismoso. Looking at now, may I now shift to the last part where I have been asked by the National Academy of Science and Technology to update the so-called Science, Technology, and Innovation Foresight. Kaya ako binibigay sa inyo ito ngayon dahil sa tingin ko ay malaki ang maiko-contribute. Hindi lang ng Failure Analysis Hub, kundi ng DMME dito sa pag-update ng Science, Technology, and Innovation Foresight up to the year 2050. In 2018, I was invited by the Academy of Science Malaysia to attend the turnover of their Science, Technology, and Innovation Foresight to their Prime Minister. So it was an honor for me to attend as as a secretary. And sabi ko, naku, pag uwi ko, kokopyahin ko ito. Gumawa ng STI Foresight ang Malaysia. Basically, science technology talaga yun. But they involved everybody in the academy, whether they are economists, social scientists, etc. So pag uwi ko, sabi ko, as usual, Yusek Geb, pagawin natin ng National Academy of Science and Technology ng Science, Technology, and Innovation Foresight document up to the year 2050. It was then 2019. Hindi pa nagsisimula ang COVID. So naibigay namin yung grant before COVID started, and nagkaroon ng COVID in late December. So while the work proceeded, marami siyempreng constraints. And so napilit din nilang lumabas yung document as promised in late 2021. Hindi pa siya yung hard copy, basta soft copy lang nung STI Foresight document in November of 2021. Lumabas yung printed copy in April 2022, 2 months before I left the DOST. But ang maganda doon talaga na-cover nila yung unang-una, yung magandang environmental scanning, looking at what are the local and global societal objectives, looking at the aspirations of the Filipinos as done by NEDA's, ano matawag doon? Ambition 2040. Okay? And of course, analyzing this to see ano yung kailangan nating mga technologies during this period na makakasolve. At tingnan din natin kung ano yung mga, meron sila mga tinawag na, nung ko lang na-encounter yung mga word na yon. And of course, threats, alam ko, yung mga black swans. Ano ba yung mga black swans na yan? So, doon ko lang naintindihan. So, in-identify nila yan. So, today, binaligtad nila, since I am now the member of the academy, binigay nila yung trabaho for updating sa akin. To oversee the updating. So, kailangan ko tulong ninyo dahil 5 taon na yung document sa November. Okay? And the academy has agreed that maybe on a periodic basis, we have to review dahil marami ng pangyayaring nangyari. Dami ng technologies na biglang sumikat, Andiyan na yung AI, okay? At saka madami na ring mga nangyari sa mundo na nagbago ang environment. Hindi lang yung physical environment or natural environment, the socio-political environment has changed. Now, there were two long-term, there are two critical pillars that were identified to achieve the Filipino people's long-term aspirations. These were science education and talent retention. Pagtanaw 2050 correctly identifies the human resource imbalance, in our STEM as a critical issue that we must urgently address. Without skilled scientists, engineers, researchers, and technicians, even the most advanced facilities will be unable to achieve their full potential. Similarly, without a secure talent pool, equipped with the right knowledge, and without equal access to cutting-edge facilities, our aspiring engineers will struggle to keep up with a rapidly changing technological landscape. Anyway, nabanggit ko na kanina yung experience ko in visiting Admatel. But looking at Admatel, it became crystal clear. More than just investing in advanced infrastructure, we should also invest in our greatest national asset, our people, particularly the youth. Our future rests on aspiring scientists and engineers who are given the resources to excel. To the students and young engineers here, do not look at failure analysis as merely a diagnostic practice. See it as an exercise whose results echo throughout society and across generations. Wield it not just as a tool that promises technical excellence, but as a tool that strengthens industries, supports innovation, protects public safety, and enhances national competitiveness. And more importantly, act as its stewards in service of the greater good. If science for the people is our guiding principle, then failure analysis, local manufacturing, and R&D become more than technical endeavors. They become pathways towards a future where Filipino ingenuity, supported by strong institutions and capable professionals, helps create safer products, stronger industries, better jobs, and a more prosperous nation at all. Dito biglang naalala, ano yun? Okay. Naalala si Secretary Montejo, okay, who is also an alumnus of the UP College of Engineering. Kung ako, science for the people ang aking tagline, siya naman, local technology works. If you will recall, talagang inisip niya kung ano yung mga local technology na kailangan i-develop na makakatulong. And isa sa mga pinag-ukulan niya ng pansin ay yung local train industry. Okay, wag na muna natin pag-usapan yung AGT, Automated Guideway Trains Transit, na nung tapos na yung R&D part, sabi namin sa UP, pwede nating ituloy na pwede nating gamitin talaga sa loob ng UP. Maraming dahilan ng UP na ayaw nila, mawawalan daw ng trabaho, ikot jeepneys, masisira yung mga halaman. So, susunod kami naman dahil yun ang kondisyon na kung ayaw ng UP, ay gigibain namin. Yun ang nasa usapan dahil R&D yung ginawa. Anyway, hindi ko sinasabing mahirap kausap ang UP dahil dito ako nanggaling, pero sa DOST, isa yan sa problema ko. Papapirma lang ako ng R&D grant. Diyos ko, 8 buwan na, hindi pa napipirmahan. Kami na nagbibigay ng pera, ano, sa legal. Siguro naman nag-improve na. Pwede na ako magsalita ng ganito ngayon kasi wala nang hahabol sa akin. Ano? Anyway, para lang makita natin yung mga sources of failure. Anyway, I think, yun nga, si Secretary Montejo did his best. Ano? And nung ma-turn over na namin sa PNR yung mga internationally tested local trains, yung hybrid trains, binigay na namin, nagamit na, ano ginawa ng PNR? Bumili ng mga bagong trains from Indonesia na doble ang presyo kaysa doon sa aming sinasabi. Yung ating National Development Corporation na ipinangakong susuportahan ng local train manufacturing, nung tinanong ko, naubos daw sa COVID yung pera nila. Nako, sabi ko nga, wala tayong mararating pagkaganyan. So let us ride the momentum of scientific and technological advancement, seize this fresh opportunity to develop expertise on failure analysis in the academe, and help shape a scientific and technological landscape that is genuinely by the Filipino and explicitly para sa ating bayan. Maraming salamat at mabuhay ang agham.
So, thank you, Academician De La Peña, for that insightful keynote address. So, truly, FA is a concrete way to bring science not only in the industry, but also to the people. And indeed, research and development should not be limited only in the research, in the classroom and laboratories, but is significant to extend for national development.
Indeed. So to express our gratitude for your invaluable contribution and for sharing your expertise with us today, we would like to present a token of appreciation to Academician Fortunato T. De La Peña. May we please call on Doc Mitch and Sir Stan to present this award.
Babasahin ko. Hello. Sige po. Sir, babasahin ko dito. Certificate namin ko lang po saglit. Sorry po. Okay, so we would like to give this certificate of appreciation presented to Academician Fortunato T. De La Peña for their invaluable contribution as a keynote speaker in the Interface 2026, a joint academe industry failure analysis symposium held on June 5, 2026 at the Department of Mining, Metallurgical and Materials Engineering, University of the Philippines, Diliman. Signed by Engineer Stan Ihera, Interface Overall Chair, and yours truly, the MME Chairperson.
Salamat.
Thank you.
To begin our first plenary session, we are privileged to introduce an expert whose career has been defined by excellence in semiconductor manufacturing and operational strategy.
With over 28 years of distinguished service, notably at Texas Instruments, in Singapore and the Philippines, our speaker has pioneered major advancement in process standardization, supply chain resilience, and failure analysis. He is a registered metallurgical engineer, a certified IATF 16949 and ISO 9001 lead auditor, and the founder of MGB Consulting Group.
His work as a pioneering subject matter expert in gas analysis has set industry benchmarks and generated multi-million-dollar savings for the organizations he has served. Today, he joins us to share critical insights on the high stakes of our profession and the true cost of oversight.
Please join us in welcoming Engineer Mark Bowado.
Good morning. As I scanned the room this morning, I'm quite pleased to see that there are plenty of professionals here in, I guess, majority energy, generation, mining, maybe not much, failure analysis, and what have you. So I hope this will be a good professional exchange and will not end up as an exchange of professionals. So before I start my talk, I'd like to sort of give you a bit of an anecdote. So before I left and did my early retirement in TI Singapore after doing 25 years, I had an opportunity to sit in some of these senior management meetings wherein there's a lot and plenty of expansion being discussed. And so in one of those discussions, sites in our in all over the world, manufacturing, Malaysia, Taiwan, Singapore, Philippines, what have you, the question rose from management is that why Philippines, right? Why do we have to expand capability in the Philippines? By the way, as a 25-year semiconductor professional, I remember what Secretary De La Peña mentioned about Doc Mena. He's one of the guru of semicon manufacturing back in the day. So kami yung mga alipores niya nung araw that we're trying to figure out metals and materials failure back in the day nung wala pa yung dual microscope. So anyway, going back to that story about why Philippines. Cut the long story short, there's only one statement that sort of resonates from that discussion, and that is because of the people and engineers and the Filipino technicians and operators. Cut away all the infrastructure cost differences between countries, and the underlying context behind that is the reason why the semiconductor manufacturing is still heavily invested in the Philippines is because of Filipino engineers. And mind you, what's happening right now is that, yeah, China is there rising up for challenges in cost and what have you. Malaysia is also catching up. Taiwan is always a pioneer, Korea. But lo and behold, for those of you that are in manufacturing, you will realize the Filipino engineers are actually the ones crafting the solution, innovating, and other sites are implementing in our behalf. So what seems to be the gap there? One is we probably are a little bit bashful and too shy to promote what we do as people. And second, probably is also a context wherein a lot of engineers are preferring them ideas to be down there on the shelves rather than being out there in the open. So I think mindset change has to be one of the forefront of how engineers communicate their ideas moving forward as we go into the realm of the next generation. So in this talk this morning, there are many reasons why you're probably here. I can see a lot of C-level people here, and maybe one of the major reasons for you to be coming out of this as a key lesson is you want to get the monkeys off your back, right? So failures are in the industry are rarely sudden. What is? Okay. Okay. Failures are rarely sudden in the industry. They often began as benign, innocuous anomalies, right? And some of you are smiling there because you can tell right away that what I'm showing on the picture is in fact a reality that we're facing right now in one of the buildings that collapsed in Pampanga. So often these structures collapse not catastrophically overnight, right? They go probably by ignoring signals, tiny cracks and what have you, right? And often these signals are ignored. And the question is why? Well, your guess is as good as mine. It's probably because of ignoring, primarily because of cost and more cost, right? So if you look at the industry today, there are staggering numbers of cases wherein products fail because of ignoring warnings from instrumentations. And right. Okay. Yeah. So in my 28 years of experience in the industry, first as an intern in Pasar in Leyte, then in Reynolds Aluminum, and ultimately in TI, first in Baguio and then in Singapore, one of the common theme that sort of resonates from this is that failure is obviously a result of a chain reaction. It normally starts not just as a big explosion, but it starts off microscopically. If you look at it from the industry today, one of the more common themes that come about during presentations on even quality and failure analysis that in the 1980s, the Space Shuttle Columbia basically crashed because of a failure in O-ring. A tiny O-ring basically brought the Space Shuttle down, right? So, what is it about failures and humans, right? That we seem to be catching up with each other. If you look at our nursery rhymes since we were young, we were singing this lullaby, and you look at the wordings. Rockabye baby, right, on the treetop. When the bough breaks, the cradle will fall, right? And even Jack and Jill. There seems to be some harbinger of that seemingly simple, benign lullaby that sort of emanates from our consciousness. So, as a result of that, the title of my talk today is Heed the Call and Before the Fall, Lessons in Failure Analysis, that I'm going to share to you. Not one, not two, but 4 cases that I've experienced personally in leading the team and solving these problems using the failure analysis tool available. When did FA began and what's the impetus for this? So maybe if those of you that are searching right now on the internet, you will find out that FA basically pretty much starts since the time man designs or decides to develop and create the bronze world steel and ultimately into our steel industry today. So the most common formally accepted origin of FA began apparently in the 1940s when the big behemoth of military complex in the 80s come up with a formalized failure analysis system wherein they come up with what we call an FMEA, and the ultimate goal is obviously to find out the failure mechanism and failure mode of a certain part and how it failed. And with that came about the failure analysis as a backbone of the process. Now, why failure analysis? I'm not gonna go down into the reason because all of us are here for the main reason of safety, reliability, and profitability. These are big words, but later on I'm gonna give you examples of cases why this is really the end result of why we're doing failure analysis, right? Obviously, safety for the very reason that the products that we are selling The service that we're doing is ultimately benefiting mankind. Reliability because, obviously, if we have the ability to produce parts that are going to be reliably used in the industry, then it will establish the operation and so on and so forth. Now, here are 4 cases I'd like to share to you in the semiconductor industry that I have personally led the team in order to solve these issues. So maybe as a quick background process description. So a silicon that is pretty much the material that starts off in the semiconductor industry is processed in the wafer fab, and then they transition into the assembly test site in the factories, and then they're shipped and ultimately consumed by the end customer. So in this process, I'm going to share to you case 1, 2, 3, and 4, and let me start off with case 1, wherein all failure analysis process that starts off in our semiconductor world began as a process flow wherein parts that are failing comes up and being delivered to us by the customer, and they say, hey, Mr. TI, we have this problem, and then please solve it for us. So it goes through a specific process flow chart in our laboratory before ultimately ending up as a report that we ultimately share to our end customer. So essentially, failure analysis begins and ends with the end customer. In my upcoming 3rd book, I have discussed this heavily in the zero defect and how this is pretty much handled in the industry today. Now, case 1, maybe for those that are interested in fructography, this is something for you. The problem here is that the silicon is cracking, right? And what happens here is that thousands of units being developed by TI and shipped to our end customers, they come back as complaints. So with that, we're talking about thousands of units, multiply that by X number of dollars, so you have millions at stake. And because of the problem there is, pretty much the IC component is failing at their board level. So when we did the analysis in our factory, we look at it from both a process simulation standpoint and even up to the material standpoint. It turns out pala that this root cause of this issue, using the FA tools back in the day, in the 90s, SEM and CSAM, during those times, wala pa tayong capability dito sa department. So it turns out that the root cause pala of this failure is that, number 1 is storage condition of the mold compound, and second is the formulation made by the vendor because they're trying to catch up with production. So in all of this root cause analysis, the solutions are out there, and we have implemented it, and the impact obviously is that in the millions of dollars because we end up solving the problem by our end customer. Second case, pretty much on the wafer level. So again, maybe not familiar with you guys that are in the energy sector and power generation sector, but the silicon is the backbone of the semiconductor world. So the cracking of the silicon on the protective overcoat layer, the problem there is when our inspection made by our incoming materials, seeing all these metal line failures, it also again emanates into thousands of dollars of failures and scrapping. So again, we did a lot of engineering simulations, and one thing that we realized, we thought is going to be a technical problem, but it ends up as a procedural issue. So ang nangyayari pala is, you can put up a lot of processes, you can put up a lot of procedures and SOP, but it just takes 1 or 2, 3 non-compliant operators wherein they take the materials from the production, nilalagay nila sa tuktok ng makina, and one thing led to another, and before you knew it, that's creating scratches. So a very technical problem is in fact caused by a non-technical cause. So those are the kinds of realizations that when you get into industry, you will realize time and time again. The solution, obviously, we come up with procedural improvements, and that simple procedural improvements led to millions of dollars of savings also because of avoidance of this problem. Third case, pretty much on a similar note, but this time around, we are doing a new product introduction to our new customers. They want their products to be heat resistant and at the same time be able to withstand the very high temperature application of this product. So contamination, normally, an FA engineer would say, oh, this is probably caused by chemical or something that is impacting the material's adhesion. Lo and behold, we thought it's going to be a very technical problem with the cost of a technical cost. But ends up, it's another thing of procedural. Plating bath solution na hindi pala pinapalitan ng on the right frequency. So those are kinds of key decisions or maybe key mishaps or key operational, we call it bonehead mistakes, that will end up as a technical problem in the long run, if ignored and if unheeded. So I'm sure all of us in the factory today that are operating in our world will have the same day-to-day troubleshooting encounters. Again, a seemingly benign procedural mishaps ending up in high-cost issue and ultimately saving TI millions of dollars. And fourth case, this is now something to do with challenging the industry for time and time again. We said, hey, semiconductor components plus salt is equal to corrosion, right? Technical equation, simple as that. But ends up, what we did was, when management came up to our technical group and said, hey, we need to come up with a way to, number one, beat the competition, number two, save costs, millions of dollars for the company, and three, render better service to our end customer. What ends up happening is, for the longest time, our semiconductor components are being shipped via air transportation. And they said, we got to do something about it. They're not going to use that part tomorrow. Some of them will probably use those parts 3-4 weeks down the road. Why are we shipping on air? That kind of question elicits our technical brain to come up with solutions and say, okay, let's do something about this. So what did we do? We were able to prove that indeed, with the right amount of packaging on our semiconductor components, with the right amount of procedural change, slight tweak in the process, we were able to come up with obviously using FA and reliability tools such as salt atmosphere test, highly HAST. A lot of those machines are, I think, not yet available in our department, but still, the point being that with the availability of these tools at our disposal, we were able to prove that indeed, semiconductor can be shipped on sea and ultimately saving tons of money for the company. So it's again another pioneering effort that were obviously championed by our team and by yours truly. So with that, those 4 cases would somehow, I hope I was able to give you an insight as to how the inner workings of the semiconductor world really is, and how what seemingly is a very heavy engineering problem potentially could be solved by a procedural change here and there, and ultimately, guided by a lot of data and analysis and tools, you will be able to paint the picture together and come up with a solution that you can express to the management team. Now, what are the lessons learned from these 4 cases? High-tech problems normally caused by low-tech causes, right? And basic engineering theory, when you're out there in the industry, the formulations, the formulas, the integrations and all that, normally most of it, I would say, applies in academia, but if you go to the real world, you're probably going to use a handful of that, right? Top-notch companies invest in failure analysis. And the safety and reliability of products and services of paramount importance. Bottom line, we don't just rely on people and handling those machines to do failure analysis, but we are also skilling them. We are sharpening the archer, not just the arrow, right? And if you think about it, it's a semiconductor world. As the products become more and more complex, there are more and more layers of silicon being put together into one another. The cost and the size of that component becomes less and less. Habang palit ng palit yung semiconductor mo, pa-complex ng pa-complex yung product. But the techniques and tool has to also come and ride alongside with the complexity. So that's a challenge right now for failure analysis team moving forward. As I said, in the industry today, top-notch companies invest not just in failure analysis laboratory equipment capability, but even core quality tools, right? For you that have ISO 9000, you've probably been harassed by these auditors time and time again. But lo and behold, you have the ability to sort of not just, if you think about it, these are indeed very, very important tools that you're going to implement in your line, but essentially the key point here is, until and unless people understand and execute these processes at the manufacturing level, at the operations level, these are all going to be papers, right? So it's very, very important. Again, top-notch companies, case in point here, TI is, as of my last check, is ninth place in the top semiconductor world and electronic world in the next coming decade. They're going to be investing, look at this number, it's a whopping $1.8 billion of R&D investment. So point of the matter is, high-tech company still investing in R&D because ultimately, as products become more complex, the return of investment of those capital expenditures in R&D will come in later on in time. Now, quick question. When I had the invitation to come and speak here, they asked me, can the Philippine industries catch up with all these developments in the semiconductor world? And I'm happy that Del Peña also mentioned that his heart right now is also in the semiconductor field. I would answer this question by sort of giving you my own story as well, right? So back in the day when I was heavily involved in our global team as the global quality manager, so I lead a group of people that are basically multinationals. And one of our team building seminars is that we need to come up with games to be able to inculcate a problem solving mindset. So what happened was, okay, in this team building session, I would like you to have this problem, right? Look at the Marina Bay Sands, because I live in Singapore for the last 25 years of my life, pretty much almost half of it. And I said, okay, using nothing but what you have on your disposal, please try to copy this Marina Bay Sands structure. Again, imagine the scenario, plenty of people, multinationals, having a team building session. And here's what they came up with, right? You got people there having their own design of an MBS. So what's the point of this story? An anecdote. One simple task, one simple problem, one simple visualization ends up in different interpretation. So this is also another lesson in communication, especially if you try to think about it. We might have the best intentions as engineers, we might have the best knowledge of analyzing failures, but until and unless that is communicated deep, clear, and crystally available to the lower end of the spectrum, is all there, not on the shelf, so to speak. So where's the Filipino engineer there? That's me, the only Filipino in the background and the senior management team. And because of my loyalty to the company, the dedication, and really the passion and desire to solve problems and showcase the Filipino capability, I was able to prove myself that, hey, Filipino engineers can make it out there, even in the global arena, in global competition. Oftentimes, we're always being judged by our color, but if you're able to articulate and communicate that you have the capability to innovate, to produce genuine solutions in an ingenious way of solving problems, let the data speak for itself. And using failure analysis as your tool and background, it will come a long way. And thanks to UP, because ultimately, my metallurgical engineering training was able to give me good foundation into having that mindset of solving problems, not in the physical metallurgy world, but in the semiconductor world. So, question, can the Philippines catch up? I think yes. Provided that we find our own niche, right? We capitalize where we excel, right? We can never compete with China. I know I was living in Singapore for the last 25 years. In one of my talk, I shared to Doc Leslie and the team that in Singapore, there is a term called kiasu, right? Kiasu is a Chinese term which means they want to be number one all the time, or they want to be top all the time. So the question is, if that kind of culture and mindset is in the Singaporean psyche, what is it in our Filipino psyche that would be able to catapult us to the next level and compete globally as an organization, as people, right? So keyword is we need to collaborate because ultimately we're living in a global world. But we should not insulate ourselves, or we should not isolate ourselves, but insulate ourselves from all this. We have to excel on our own terms. We have to investigate deeply, challenge assumptions, connect, understand and protect the safety and public trust of people. Until and unless we do that to ourselves and to our own industry, then the Filipinos will always be looked at as a third-class citizen. But I think this quotation from Douglas MacArthur, 1940s, and I would like to borrow it from him, when he said, and give me 10,000 Filipino soldiers, and I will conquer the world. And I'm going to replace that word soldiers to give me 10,000 Filipino engineers and I will conquer the world. So with that, I end my talk and thank you very much for listening.
Thank you, Engineer Boado, for that enlightening talk. We now have a few moments for a quick Q&A session. If you have any questions for our speaker, please raise your hand and our ushers will assist you.
Very informative and inspiring. I just want to relate your talk to what I heard from Still Asia, that they are
Yes, sir.
planning a big expansion. How does that relate to our conclusion that we can still catch up?
In terms of the steel industry, sir, the context, and you're saying that they're going to be expanding their operation. I think ultimately industries will expand at some point in time because the world demand is going to expand ultimately. The question now is not just about cost. It's also about the capability of people that are going to be involved in operating the process in industry. And ultimately, it's also about having a good, solid industry partnership between academe industry and at the same time putting that into context wherein, for example, in the Singapore context, at some point, they said that they cannot compete with China in terms of cost in key industries. So they have to pivot their way and invest in other areas, for instance, biotechnology and fintech. And at the same time, in those areas, they think that they have the edge, they're able to attract top talents across the world. And at the same time, they're able to also reinforce that process and therefore start that industry where it began and at the same time expand it over time. Maybe another way to pivot that question, sir, is that in one of my last project before I left TI is that we're developing humanoids to replace our factory operators. And humanoids, obviously a lot of steels needed for that, right? So there's going to be an explosion of steel industry in the future. And here's an interesting anecdote as well to probably contextualize the answer. Cost-wise, we have 4 vendors, Germany, US, Japan, China. Guess who's the winner? It's China. Cheaper and faster in lead time. They're able to develop. And when we look and visited yung company that has that capability, it turns out this guy is a PhD graduate from mainland China, and Singapore government sponsored him to his PhD, and the Singapore government also gave him the incentive to start up his own company, and now that he's gathering customers for his humanoid project, the Singapore government has its own piece of that investment. So as the company expands, the government also has its own ROI. So maybe in that context, expansion-wise, so to speak, there's a big factor of that, not just hinged on the industry itself, but also with the government and industry partnership. So I hope na-answer ko yung yeah. Okay, thank you.
Sir Tito.
Good morning, everybody. My question will probably throw us off, all of us. My problem, Mark, is that we are not graduating enough engineers in UP. The statistics show that only 63% of our freshmen ultimately become engineers. 63%. Drop out 37%. So again, only 41% finish in 4 years. Add 1, 2, 3 years, become 63%. So, your bottom of the talk is people, and we are failing there. We are failing because we only graduate 63%. So, in other words, failure analysis, we have to start. Gentlemen and ladies, we have to start failure analysis. Why are we failing? Why are we failing? And that is our problem. That is, to me, that is the biggest challenge. Thank you.
Thank you, sir. In one of the talk that I attended, talks about patent and patents and ideas and patents. And it's disheartening to note as well that, sir, the problem that you are having also in the Philippines engineering graduates is probably the same across the world, because right now China is producing so much patent in technology that the US cannot catch up as well. I echo what you're feeling, Sir Tito, because luckily and good thing my sons graduate. One is in engineering electronics, the other one is in science in Singapore. But that challenge, I guess it's a challenge, Sir Tito, no? That the foundational principle of engineering starts off at the very early days of the young person's life. Alam mo, Sir Tito, ang nami-miss out natin is that sometimes these technologies is supposed to aid us, but it ends up making our kids dumber rather than smarter, right? And so it's always like an oxymoron, because here you have developed this high-end tech to improve your talk, or high-end high-end machines, but you end up losing that edge in terms of solving problems. And maybe, I guess, to allude to what Sir Tito is saying, we should not just look at it from a numbers perspective, but also from a cultural perspective, and at the same time, problem there is that we are, as a country, we are training people to be employees, not employers. And I think that's another thing, in addition to the challenge that Sir Tito is observing. In Singapore, it's the other way around. They're not just teaching their kids to be employee material, but also employer material and entrepreneurs. Because it's one thing when you have the idea, it's another thing when you have that idea implemented and make money, right? So those are key thought processes that I think would be able to propel us. And mind you, as a country, we should forget about catching up with Korea or Taiwan. They're playing a different game already. But as a country, like I said, we should be able to stand on our niche, capitalize on our strength, and from there, take off, right? And I still believe that as a Filipino engineer, the Filipino mindset is able to compete globally. Thank you, sir.
Good morning ulit, Sir Mark. Now, thank you again for the talk that you shared with us. Now, very inspiring. I'd like to pick up from what Sir Tito has just asked about, and the niche that you mentioned a while ago. No, so coming from, of course, being trained from the university, and then having gone to another country to work and, of course, experience the culture there. You know, so siguro I'm not so sure if there's another build-up that you can make from the question, from the answer you gave to Sir Tito, but essentially, I guess it's also asking about where do you think, probably in the training program, that's the whole spectrum probably, no, from kinder ba to advanced education, no, in the country's context, kumbaga. Should we now possibly look at or evaluate and probably integrate some improvements so that some kind of the kiasu culture might be integrated, or the employer mindset can be integrated, no? So siguro from on that question then, I also connect to the next question na, if you are to also suggest niche area where the country can build up on, or siguro anchor on, no? Can you also identify for us also that we can also base our improvements, or parang siguro yung how do we modify our ways of doing things then siguro with that niche area as our probably North Star? So siguro yun yung dalawang questions, sir. Thank you.
Yeah, so ang sagot ko dyan, Ma'am Les, is that, well, the first question, culturally, as Filipinos, yung ating way of problem solving is unique, right? When I say problem solving is unique, case in point, give a problem, for example, a technical problem to an engineer in the Filipino semiconductor context. The word that will come up with him is remedyo. Anong remedyo gagawin natin dyan sa makina na yan? Right? That culture, to me, is both a double-edged sword. Because on one hand, you're finding way how to remedyo and work around solving the problem. But on the other hand, you're also being challenged because that remedyo might end up causing more problems in the long run. Kaya nga double-edged sword. Second, if you give the same problem to, let's say, a Chinese engineer or Singapore engineer, anong gagawin niya? Pupunta sa libro, pupunta sa manual, pupunta sa specification, titignan niya how to solve the problem. So yung ganong mindset, where do you think that come from? Upbringing, education, culture. So I hope that answers the first question. On the second question, in finding our own niche as a North Star, for some reason, ang Pilipino ang galing gumawa ng meme, right? And we always try to find some, maybe a relief from a tight situation. And yung social media is supposed to be, or AI for that matter, I would guarantee you, ang next na gagawin ng Filipino engineers, AI hindi na robot na maggagawa sa factory kundi robot na sasayaw. You know what I mean? Robot na kakanta. See, that's the unique thing about Filipinos, right? So North Star-wise, if you think about it really deep, it has something to do with the socio-cultural and maybe economic situation of our country, right? So I hope that I was able to give you some insight as to where can we take our country or next batch of engineers to the next level, and probably how we can pivot our way to follow that North Star. And I hope my answer makes sense to you. Okay. Yes, sir.
Hi po, thank you po, Engineer Boado. I'm Odric from the DOST Philippine Textile Research Institute. So maybe a different field, but I'm actually in the public sector. And one of the things, so you talked about yung role po ng academe in the industry. So I was wondering what the role of the public sector naman po could play in establishing yung, or basically in making us learn the lessons of failure analysis. Given for me, the two levers of public sector are really the, let's say, policy and finance, yung public sector financing. So what do you think could yung intervention naman po coming from us sa government side could be to be able to, for us to heed the call before the fall? Thank you.
I don't know how you call it, sir, but cycle time, turnaround time, we have to move fast. Mind you, the way the semiconductor pace works in line with the public, China for that matter, story to answer that question. Our China factory in Chengdu, when I went there to see the factory being built, this Chengdu site is just new, huh? It takes Taiwan engineers to go and help build the site, not mainland Chinese people. Some engineers went there in the Philippines to help build the factory. Public sector-wise, yung China, local government recognized that. In a matter of 5-8 years, they were able to turn around because of very fast response to service, recognizing that number two, without the fast service to be rendered to the industry from the public sector, they will lose out the challenge of bringing up that industry to the next level. So turnaround time, cycle time, whatever metrics you're measuring is very, very important because, hey, industry cannot wait for a permit to be processed by the government. I can tell you right now, industry is looking at 10 steps of how to compete globally. Maybe the government is slowly catching up in our context, but other countries, they're already 3-4 steps ahead of us. So cycle time, turnaround time, approving permits and what have you, those are very, very important. I guess one word also is bureaucracy. We need to really, really cut it down to the bare minimum. I can tell you right now, in China application permits, back in the day, to import material, long list also. Bureaucratic din sila 100 steps. Now, mga 50 na lang. They're improving, even with the 1.3 billion population. The Philippines, maybe as high as 10 pa rin, or 100 pa rin. So, comparatively, mabagal pa rin yung ating public involvement from as far as supporting the industry to propel it to the next level. I hope that answers your question. Thank you. Yes, sir.
Good morning, sir. I'm John from Triple M. Actually, it's connected about turnaround time. I understand that failure analysis needs time to unlock the mysteries and solve the case. However, in the industry, I understand as well that a delay means loss of money. So I'm just wondering, in the 4 cases that you presented, what's the average duration to solve a case? Because for our students, it's 1 semester, but in the real world, I understand that it needs to be immediate. So for the 4 cases, what would be the average duration for the failure analysis process?
Back in the 1940s, Iho, I don't have the number.
But currently, right now, with the technology that we have.
Oh, so you want to compare ano yung turnaround time then and now? Ganun ba yung question mo?
The cases, just to give the students the need to be immediate, like the urgency.
Right. I would answer that by saying customer time. In the industry kasi, customer turnaround time is our basis eh. If the customer says, I want the result within 48 hours, oh my gosh, lahat kami pupunta sa linya to simulate and run the experiment and come up with the report. So there's 2 ways of answering that question. One is customer turnaround time, maybe in a matter of hours. Automotive customers, they want it within 48 hours. Aerospace, military, 24 hours. And 1 day delay, millions of dollars of payment. That is for the semiconductor world. Maybe for other industries, maybe the boiler is waiting, so you need to come up with a failure analysis of that metal. It could be 1 day boiler loss, also runs in the millions. So I would say turnaround time dictated by the customer and turnaround time dictated by your own internal metrics, maybe management, maybe 3 days, 4 days, 5 days. So hours for that matter for some, especially for operations like maybe oil and gas or power and energy generation. So we're talking about hours and days and not weeks. So that's the turnaround time. I hope I answered your question. Thank you. Yes, sir.
There are a number of issues that have been raised that I would like to. Unang-una yung tungkol sa needs centers na tinanong ni I think very, very important. If we really are serious about catching up, okay? And maybe gagawing updating ng STI foresight can be one avenue to identify this. Yun naman question about the public sector. Ang problema, hindi naman huli sa pag-iisip. Ang problema, nag-uumpisa tayo at hindi tinatagpos. No? Ayoko naman purihin si President Marcos nung inumpisahan niya yung 10 major, ano ba yun? Ilan ba yung major industries at that time? You mentioned Pasar. It is one of them, di ba? Tito, baka mas alam niya kung ilan yung major industries na sinimula noon. But ilan doon ang natira ngayon? Ilan ang nag-survive? Ano? Yung sustainability aspect napakahirap sa Pilipinas dahil sa decision-making processes. Hindi tayo huli sa nuclear. Tayo ay isa sa mga una. Ano? Yung mga kasabay natin, 40 years ago, umaandar pa yung kanila. Tayo, babalik na naman tayo, mag-uumpisa na naman. So yung sustainability aspect ay talagang isa sa mga ano yan, parang failure points, ano? And tungkol naman dun sa binanggit kanina ni Tito, about 67% are surviving ba or graduating? 63 ang gumagraduate. Naalala ko nung panahon natin, hindi naman tayo diretsong pumapasok sa College of Engineering, di ba? May 2 taon tayong pinagdadaanan sa University College na after nung 2 years at tatapos mo yung mga requirements, mag-a-apply ka sa College of Engineering. Hindi ka naman siguradong tatanggapin. Kaya nung panahon na yon, alam naman ni Tito, 50% ay gumagraduate. Ano tawag dito? 25% ba yung on time? Basta yung, nung panahon natin, ilan yung gumagraduate ng 5 years? Ilan yung gumagraduate ng 6 years at ilan gumagraduate ng 7 years or more? Ano? Yun yatang 6 years, yun ang 50%. Yung 5 years, yun ang 25%.
Yeah.
At yung 7 years and more, yun yung another 25%. Ano? Kaya noon, ano ginawa nung ating screening committee for admission, chaired by Romy Manlapas, inanalyze niya kung ano ang probability of graduation ng mga pumapasok sa, nag-a-apply sa UP College of Engineering. And he found out that if your average grade in math, physics, and chem is lower than 3.4, your probability of graduating at the college is only 5%. So since that time, lahat ng lower than 3.4 ang average sa math, physics, and chem, hindi na tinatanggap sa UP College of Engineering. Meron pa isang factor na nakikita ko ngayon, kasi may mga kilala ko na engineers na pinipilit mag-engineer yung mga anak. I think we should let them do what they want. Thank you very much.
Thank you, sir.
So, thank you for the participation of our audience, and thank you, Engineer Mark Boado, for your meaningful insights. And so, to express our gratitude for your time and expertise, we would like to present this token of appreciation to be presented by our Department Chair, Doc Mitch.
We would like to give this certificate of appreciation to Engineer Mark G. Buado for their invaluable contribution as plenary speaker in the Interface 2026, a joint academe industry failure analysis symposium held on June 5, 2026 at Department of Mining, Metallurgical and Materials Engineering, University of the Philippines, Diliman.
So now that the first batch of our plenary talks are now done, we will now take a short coffee break. So we are to be back by exactly 10:30 a.m. to continue our technical plenary sessions. There are snacks and drinks in the anteroom outside the auditorium. And we kindly request the attendees to please present their food stubs to the committee to claim your snacks.
For our dignitaries and guests of honor, please stay in your seats. May ushers po na magbibigay ng food ninyo. Thank you. Following the break, we invite our technical committee, Engineer Edwin Roven Canyazal, Dr. Mitch Irene Kate Oyales, and their team to begin the evaluation of the poster presentations and smoking gun exhibit in the swell room.
So furthermore, we invite everyone to explore the poster presentation and smoking gun exhibit located in the swell room at the ground floor. So this showcase highlights the rigorous evidence-based research in failure analysis conducted by our talented undergraduate students.
We also encourage your active participation in selecting the recipient of the People's Choice Award. Please cast your vote for your favorite exhibit by scanning the QR codes displayed on the screen or those located throughout the auditorium and exhibit areas. participation in the selection of the People's Choice Award for the smoking gun exhibit. So please cast your vote for your favorite exhibit by scanning the QR codes displayed on the screen and those located throughout the auditorium and exhibit areas. So as you can see, meron pong mga QR codes dyan sa gilid. You may scan the QR codes to vote for your favorite smoking gun exhibit entry. Thank you. So again, we request everyone to please return to the DMME auditorium so we can start immediately.
Welcome back, everyone. I hope you enjoyed our AM snacks. So now we will proceed with our next plenary session featuring two experts from our partners at the Semirara Mining and Power Corporation.
First, let us please welcome Engineer Ansel Rom Mendoza, Performance Superintendent at Southwest Luzon Power Generation Corporation, bringing over a decade of specialized expertise in coal power plant operations. They focus on optimizing plant efficiency and operational reliability. Please join us in welcoming Engineer Ansel Rom Mendoza.
Accompanying him is Engineer Mayet D. Marco, Performance Superintendent of SEM Calaca Power Corporation. With nearly a decade of experience in coal-fired power generation, she leads critical initiatives in plant monitoring and boiler inspection to ensure safe and reliable operation. So the speakers may now proceed to the stage.
Morning po. Morning po sa lahat. So good morning po ulit. So for today's discussion, focuses on critical issues shared across manufacturing, construction, energy, transportation, mining, electronics, aerospace, and heavy industries. The growing need for advanced failure analysis capabilities and the widening gaps that continues to challenge operational reliability, safety, and competitiveness. This is why failure analysis can no longer be treated as a reactive activity performed only after catastrophic breakdowns occur. It must evolve into strategic capability that supports predictive maintenance, continuous improvement, quality assurance, and long-term sustainability. So for my part, I will discuss the advanced failure analysis through in situ metallurgical testing and industry academe collaboration. So the current state of electricity consumption in the Philippines reflects a heavy reliance on fossil fuels, which supplies about 3/4 of the nation's electricity. So coal alone accounts for more than half of this consumption, underlying a significant dependence on this energy source. Consequently, coal plants are the backbone baseload for almost more than 100 years. So consequently, when the coal-fired power plants experience unplanned outages, the power system may face or may cause grid instability, higher repair cost, production loss, and safety risk. So what is the major contributor or cause of these plant outages? So based on the statistics, the major contributor on the duration or even also in the frequency is the boiler tube leak or pipe rupture. So in this force outage may cost millions or billions lost per hour, and also reduced output, and also the safety risk. So that's why the failure analysis is not only forensic work. It is essential for power plant reliability, safety, and properability. So what are the different high energy piping failures? So in the plant, the high energy pipes are the main steam lines, main steam pipes, and also the hot reheat lines. So this one is the connecting the boiler to the high pressure turbine. So these pipes experiences, just for a background, so almost in our plant is almost 13.2 megapascal and around 535 degrees Celsius temperature. So the other plant in the PC, it almost 15 megapascal and the temperature 539 degrees Celsius. So yun yung mga high energy pipes namin sa power plant. So ano-ano ba yung mga failures na possible sa high energy pipes? So there are the creep rupture, the thermal fatigue, stress corrosion and cracking, type 4 cracking in welds, erosion corrosion, fatigue due to cyclic loading and cyclic loading. So what are the boiler failures naman sa plant? So the boiler in the plant exposed siya sa almost 950. In our plant, 950 degrees Celsius. So in the other plant, the 2x300, it's almost 1,300 degrees Celsius. So ano na yung mga failures sa boiler tubes? So these pictures are actual boiler tube failures na sa plant na experience namin. So what are the boiler properties? The long-term overheating, short-term overheating, the fire side corrosion, the water side corrosion, the hydrogen damage, the flow accelerated corrosion or yung FAC, and the erosion from ash particles. So this one is the example of the erosion. This was also an actual photo of the ash erosion boiler tube leak. So in our plant, to avoid this kind of failures, so we have a program, or in the plant industry you call it asset plan. So one of the asset plan in the plant is the in situ meteorological testing. So what is in situ meteorological testing? So it was a testing directly at operational site. So this was no need to remove the ship, or no need to remove or ship the components, kasi yung mga main steam line, so it's almost 430 to 450 po yung diameter niya. So almost half a meter. And also real-time monitoring. So example ng in situ methods, so we have the hardness testing, the replication technique o yung replica, the corrosion monitoring, and the microstructural analysis. So this one is example photo sa plant na ginagawa po namin. That one is main steam line and also the hot rate line. So the top is the NDT or sa flow testing. The below, in this one, the below is the penetrant test. So the other one is the magnetic particle, and in the rightmost is the replica testing. So what are the benefits po ng in situ testing na ginagawa sa planta? So number one is reliability. So unplanned shutdowns are amongst the most expensive operational risk in the stress tree. So because of in situ testing, we can early detection of degradation, identification of abnormal well patterns, monitoring of corrosion activity, tracking of fatigue accumulation, and detection of thermal damage and creep. So when testing can be performed directly at the site, organizations avoid lengthy delays associated with the component transport, laboratory schedule, and external consultation. So also, the most and the one also, the benefit is the safety. So because of in situ testing, so we enhance safety and risk management. So because of this, material failure can have severe consequences. What are these consequences? The pressure vessel rupture, the pipeline leakage, structural collapse, electrical system failure, mechanical failure of rotating equipment. So because of in situ testing, improve risk management by providing continuous insights into health and critical assets. So this allow operators to intervene before failure escalate into accidents. So that's why in situ is one of the benefits is the safety. The other one is the cost savings. So through the systematic testing and data analysis, industries can improve component design, reduces emergency repair cost, optimize operating parameters, refine maintenance strategies, extend equipment lifespan, and improve product quality. So this creates a cycle of continuous improvement driven by evidence-based engineering. So and also one of the benefits is from reactive to predictive. So because of this in situ, so moving from reactive to predictive failure management. So in situ meteorological testing enables organizations to assess material condition directly with operational environments without waiting for a catastrophic failure. So instead of asking why did the equipment fail, so industries can begin asking how do we prevent the failure before it happens. So that shift represents a major transformation in industrial management. So while the benefits of in situ meteorological tests are clear, so reducing downtime, improved asset reliability is enabling more informed maintenance decision, the question remains, why is adoption becoming increasingly important today? So the answer is the following challenges that our industry is facing today. So ano ba yung mga needs at gap ng industry natin ngayon? So one of the challenges is the foreign lab dependence. So there are limited access to advanced failure analysis facilities. So many industries still rely on external laboratories located abroad for meteorological testing and root cause analysis. So this creates several challenges. So one is the long turnaround time. for critical investigation, high testing cost. So yung dati yung company namin is also, nagpapadala din po kami sa abroad ng aming mga boiler tubes, high energy pipes. So there are long turnaround times, almost 2 months, 3 months, bago dumating yung analysis. And there's also a high testing and logistics cost. So delay corrective actions, kasi kung mag-iintay tayo ng 3 months, so the plant is already running na. So possible, dahil late yung ating solutions, so possible maulit. So yun yung magiging That's the one is the challenge. So reduce responsive during operational. So for sectors operating continuously, gaya nga po namin, power generation, mining, manufacturing, transportation, and petrochemical processes, delay in identifying the root cause of material failure can significantly affect the productivity and probability. So, and also, challenges is the reactive maintenance. So, the reactive rather than preventive maintenance culture. So, yun po yung sa iba, reactive, not preventive. So, major gap across the industries is continued dependence and corrective maintenance. So, instead of predictive and preventive approach. So, in many cases, components are only inspected after visible damage occurs. Failure data are not systematically collected and analyzed. So lessons from previous failures are not instituted, and also metallurgical degradation mechanism remain poorly understood. So without a strong failure analysis system, organizations often repeat the same operational mistakes, resulting to recurring equipment failures and unnecessary cost. And the other also is the weak industry-academe research linkages. So another major challenge is the disconnect between the academe research and the industrial applications. So universities possesses technical expertise but lack in industry exposure. Ang industry naman have operational problems but limited research partnership. So research outputs are underutilized in real operational environments, and opportunities for innovations and technology transfer remain untapped. So these gaps limit the development of local relevant solutions tailored to specific operational environment and material challenges. So yan sir, yan po yung mga challenges natin. So that's why, so if the industry is facing these gaps, the next question is, who can help us close them? So ano pa yung paano makakatulong? So one of the answer lies much closer, we often realize, are universities and research institutions, so like UP. So yun nga po, from ProRain labs to local partnership, yun po yung ginawa ni SMPC, SAPC, at saka po SLPGC. So last 2021 po, so history ni SMPC at saka po ni UP, so last 2021 to 2022, kasi nga po, ever since po, we are almost from 2014 po, we are the boiler tubes failures are dinadala po namin sa abroad. So from 2021, we tried UP po, to be specific, the D-triple-ME. So we give them 2021-2022 the tube failure po. And the analysis is also almost the same, and mas ano pa po siya, from UP is mas detailed. Kaya po, from that, so yun nga po yung previous namin, so costly, slow to earn on, so the management invested in local capability po. So we have partnership with UP Diliman po established, and then equipment donation po. And then after po nung failure, nung binigay namin sa kanilang tube material, so 2023 po, we give when we punta po kami dito sa DUP Diliman, so we search kung ano pong pwedeng may tulong po ng planta. So we have equipment donation po. Kasi wala po sila dun meron po silang pang-analyze, but the surface preparation po ng mga boiler tubes, yun po yung donate to be specific po ni SMPC po. So from equipment failure po, equipment donation po last 2023, so noon pong 2025, so established na po yung failure hub. And then 2020, last year lang po, August 17, 2025, so nagkaroon na po kami ng on-site testing. So lahat po with SLPGC with 90 points, and then SCPC with almost 200 plus points po, and almost I think 10 to 15 boiler tubes po yung ina-analyze nila. And surprisingly po, they are mabilis po sila. Ano po? Just experience namin. So magagaling po sila. Sila po yung mga kasama namin. Ano po? So, yes po. And then, yun nga po, ngayon is ipinapresent namin sa inyo yung nangyari po sa amin. So to be, ano pa po, i-discuss po nung kasama ko yung mismong engagement po nila sa amin. How successful po yung engagement na ginawa nila. So we've discussed so why industry and academic partnership matters po? So kaya ba't po ba namin naisip yung industry and academic partners? Because academe po, so brings research expertise, specialized labs, and skills researchers. So while the industry naman po, we have operational challenges, we have funding and data po, and we also have applications to environment. So when we discuss the needs of academy, so ito nga po yung dalawa. So what happens when we bring together the industry expertise, operational challenges, academic expertise, at saka po yung research capability? So pag isama po yung industry, tsaka po yung academic, ito po yung mga characteristic. So pag pinagsama natin siya, sir, so this will give us number one is developing the future engineers. So one of the greatest long-term benefits of the collaboration is the workforce development. So students who participate in the industry-supported research gains hand-on testing. So actual po yan po yung, sa UP po ito mismo yung picture. Po. So hands-on experience, we have industrial challenges, so yan po yung ano nila sa amin sa planta. And then mentorship, so we have yung po yung change of knowledge po, kung ano po yung experience namin, experience po nila. And then also the workforce development. So yan po, actual pictures din po yan sa planta. And also ano ba yung benefits pa ng ating ginawang collaboration po or yung partnership. So we bring innovation ecosystem. So creating innovation system, strong partnership between industry, universities, and government agencies and research institutions create innovation ecosystem capable of driving national development. So such ecosystem encourage shared facilities and expertise, joint research programs, technology incubation, knowledge exchange, and also collaborative solving problem. Ano po? And also one of the benefits of this partnership is the long-term commitment. So success requires long-term commitment. So because effective collaboration requires shared goals, open communication, sustained investment, and also the mutual trust and continuous engagement. So the most impactful partnership are not one-time projects. So they are the long-term relationships built around shared innovations, objectives, and measurable outcomes. So today, industries face pressure to improve reliability, safety, sustainability, and competitiveness in a rapid changing technology landscape. So failure analysis and in situ meteorological testing are no longer operational technical functions. They are strategic enablers and operational excellence. To move forward, we must strengthen local failure analysis capabilities, invest in advanced in situ meteorological testing technologies, promote predictive and preventive maintenance culture, support workforce development and material reliability engineering, expand meaningful industry, academic partnership, and foster innovation ecosystem. Because by working together, industries and academic institutions can create smarter, safer, and resilient engineering systems. So to continue this conversation, I would like to turn the floor over my colleague, Ms. Mayet, who will share the examples of successful and meaningful partnership with UP, DMME, and how such collaborations have delivered value to both of us. Thank you.
So good morning po everyone. On behalf po ng SEM Calaca Power Corporation and Southwest Luzon Power Generation Corporation. Gusto po namin mag-extend ng aming gratitude and gratefulness sa UPD MME para po sa experience na ma-share namin, yung actual experience namin bilang power plant industry on how the experience as end user sa kanila pong mga metallurgical services. So today, I will be discussing how our collaboration with UPD MME has supported our efforts in failure analysis, metallurgical assessment, and asset integrity management. Rather than focusing on the technical principles behind metallurgical evaluation, my objective is to share the perspective of an end user, how these services have contributed to our reliability programs, and the value they have delivered, and why this partnership continues to be important to our organization. So to provide some context, SEM Calaca and SLPGC operate generating units that was commissioned in 1984, 1995, and 2016. This means we are managing assets with service exposures ranging from approximately 10 to over 40 years. As our assets continues to age, one of the most important questions we need to answer is what is the actual condition of those critical components, and how long can they continue to operate safely and reliably? Answering that question leads directly to the challenges shown on the next slide, which among those primary concerns are aging boiler pressure parts, as what Sir Ansel have mentioned, long-term creep exposure of our high-energy piping systems, material degradation due to prolonged service, and remaining life of critical assets. Addressing these challenges requires specialized metallurgical expertise capable of evaluating material condition and translating findings into practical engineering recommendations. So for these next slides, our collaboration with UPD MME has evolved over several years and across multiple facilities. So as what I've mentioned earlier, we started this partnership way back 2021, where we just, it started on a simple sending of a boiler tube sample to UPD MME to see their capabilities and to compare this on our international providers. So we can measure or we can gauge if we can really depend on local expertise. What started with failure analysis activities gradually expanded into metallurgical assessments of boiler components and high-energy piping systems. This slide summarizes several of the major engagements completed up to date. What is particularly noteworthy is the diversity of applications supported by UPD MME, from failure investigation to large-scale field metallography campaigns involving hundreds of replica test points. For us, these repeated engagements reflect the confidence that was built over time through consistent technical performance and professional collaboration. So the next few slides will show UPD MME in action. These photographs provide a glimpse of the UPD MME actual field activities within our facilities. One of the things that we have appreciated most was that engagement extended beyond laboratory analysis. Their team actively participated in field assessments, worked alongside with our engineers during outage activities, and developed practical understanding of the operational context surrounding each project. For example, during the Unit 3 field metallography campaign, approximately 90 test points were completed across critical components, including our main steam, hot reheat, boiler stream drum, and plate and reheater and superheater sections. Similarly, during the Unit 1 field assessment, the scope expanded to over 200 replica test points, together with metallurgical evaluation of extracted tube samples that were actually sent to their laboratories. These activities required not only technical expertise, but also significant field execution capability, coordination, and commitment to meeting outage schedules. So, as a proof po of their continuous improvement on their field, so way back in 2025, their first engagement was in our Unit 3, SLPGC, wherein they completed 90 replica test points in 11 days. The previous slide I've shown earlier. But during their field assessment for Unit 4, given the same number of replica test points, they managed to finish it on 4 days only. So it only showcased their strong adaptability to our environment in the plant, so they can finish and will not cause delays in our outage schedules. So the next slide, paano po ba yung ginagawa nila sa planta namin or within our facilities? So across these engagements, UPD MME employed a structured and systematic metallurgical assessment methodology. So their process begins with surface preparation and replica collection, followed by in situ metallurgical examination and preliminary evaluation of material condition. Collected replicas then undergo detailed laboratory analysis where microstructural features are examined and assessed against applicable material specifications, operating history, and accumulated service exposure. The ultimate objective is not merely to characterize material condition, but to provide meaningful insights regarding degradation mechanisms, asset health, and remaining service life of our critical components. This information serves as an important input in our maintenance planning and asset integrity programs. So the next slide, what we really receive as an end user. So from the perspective of a power plant operator, the true value of any metallurgical assessment lies in the quality and usefulness of their technical deliverables. The reports provided by UPD MME are comprehensive and well-structured, encompassing from visual examination findings, metallographic assessments, microstructural interpretations, condition evaluations, identifications of degradation mechanism, and engineering recommendations. Beyond presenting technical observation, the reports establish the relationship between those observations and the practical implication for continued operation. This allows us, plant engineers and decision makers, to better understand our component condition, evaluate their risks, and determine appropriate monitoring and maintenance strategies. But beyond the report, what really made the difference? So, in this talk po, we're trying to compare them on international providers. So, what made the difference? I've mentioned 4 major elements here. So first, there was a strong culture of technical engagement and discussion. Throughout the assessment and our engagement, preliminary observation and findings were openly shared and discussed even before the issuance of their final technical report. This enabled our engineering teams to begin evaluating potential actions and considerations much earlier in the process. So within the timeline po ng aming outage schedules. Second, the relationship was highly collaborative. Rather than functioning solely as an external consultant, the UP team actively worked with our engineers to understand operating conditions, maintenance history, and plant-specific concerns. This collaborative approach significantly improved the relevance and applicability of their recommendations. Third, responsiveness was a major advantage. Because the team was locally accessible, coordination was significantly more efficient. Questions could be addressed promptly, technical discussions could be arranged quickly, and support was readily available whenever clarification was needed. Finally, and perhaps the most important is there was genuine commitment to knowledge transfer. As plant engineers, we are not metallurgists by profession. However, their team consistently explained their findings in a manner that was technically rigorous yet understandable to engineers of other disciplines. So yung mga microstructure po na iyan, hindi naman po namin yan ganun talaga ka-detailed na maiintindihan. So one of the advantage that we've experienced with their team is that they really tried to explain to us in a manner na pwede namin siyang mas madaling maunawaan and makapag-isip kami ng strategies on how we will deal with those findings. They help us understand not only what was observed, but why it occurred, what the implications were, and how those findings should influence future decisions. For us, this transformed the engagement from a transactional service into a genuine technical partnership. So, cost savings through local expertise. Beyond the technical benefits, our experience also demonstrated the economic value of local expertise. To maintain confidentiality po, the comparison I presented is based on a relative cost basis rather than using the actual project values. For a comparable scope involving metallurgical assessment and on-site replica testing, engagement with UP MME resulted in significantly lower project costs compared to our previous international provider. So to be more figurative po, we've realized a 65% reduction in the cost for the programs that I've mentioned earlier, the metallurgical assessment, the on-site replica testing. We did this on a comparable scope po, same number of test points and same number of tube samples that were analyzed. However, the more important point is not the cost reduction, but what made it possible. Ultimately, this graph does not simply illustrate lower cost. It reflects the value that can be realized when world-class expertise is available locally. So for this slide, I will be emphasizing the importance of building confidence in Filipino expertise. This experience ultimately strengthened our confidence in the capabilities of Filipino engineers, metallurgists, and researchers. Through actual plant failures, metallurgical investigations, high-energy piping system assessments, and asset integrity evaluation, MME demonstrated the ability to perform independent technical assessments using structured and standard-based engineering methodologies. As industry practitioners, we placed significant importance on credibility, technical rigor, and practical applicability. Our experience showed that these qualities are not exclusive to international organizations. The expertise that we once sought primarily from overseas providers can also be found, developed, and strengthened here in the Philippines. For us, this is perhaps the most meaningful outcome of this partnership. So before I conclude, allow me to leave you with 4 key takeaways from our experience with their team. So first, they demonstrated technical capabilities that effectively supported our reliability and asset integrity objectives. Second, the value of engagement extended beyond technical reports through meaningful collaboration, responsiveness, and knowledge transfer. Third, local expertise can provide significant economic value while maintaining the quality and depth of technical deliverables required by industry. And finally, our experience reinforced the belief that Filipino engineers and metallurgists possess the capability to support critical industrial assets at a level that meets global expectations. On behalf of SEMCALACA and SLPGC, I would like to express our appreciation to UPD MME for the partnership that has been established over the years. We look forward to continuing this collaboration as we collectively work toward improving reliability, strengthening asset integrity programs, and advancing industrial engineering excellence within the Philippines. Thank you so much and have a good day.
We appreciate the technical expertise shared by Engineer Marco and Engineer Mendoza. So truly, we as the failure analysis engineers, we recognize the importance of the partnership between the company and the hub, as well as the need for these services in the Philippines, especially for power generating companies, to propose proactive solutions.
So moving forward, we are privileged to welcome our next plenary speaker, a distinguished authority in quality systems and industrial forensics. Engineer Marlon Yana is the Technical and Operations Director and co-founder of NASAT Labs with more than 2 decades of experience in the semiconductor field.
Having held key positions at Philips Semiconductors and Deca Technologies, he now serves as a technical assessor for the DTI PAB. Holding both a BS and MS in chemical engineering, he is a renowned specialist in fault isolation and advanced imaging. Please join us in welcoming Engineer Marlon Yana.
Good morning. Yeah. So I came from the semiconductor. I believe yung first guest natin kanina is also from the semiconductor. I been in the failure analysis industry for more than 15 years. And the semiconductor, for you know, no, they contribute more than 60% of our export. They are a very important industry. So kung kanina nag-scan ako ng mga papers, wala yatang representation from the semiconductor. No? So apparently my instrument are somehow related to the semiconductor application. X-ray photoelectron spectroscopy. So dito sa Philippines, wala pa tayo nito, no? This is marami na pong technology na, for example, light emitting diodes, no, yung mga ganong applications, and even surface contaminations of many semiconductor devices, kailangan natin ng surface analysis machine. So kung ang theme ng ating event ngayon is interface, ang aking i-discussion naman ay surface. So medyo related siya, no, sa surface. Anong forward nito? Ito? Ito? Ayaw? Ito? Okay. Yeah, so my company is NASAT Labs, Nanotech Analytical Services. We houses 4 scanning electron microscopes from the tabletop, which can go up to 100,000 times magnification, to a cold field emission that can go up to 2 million times magnification. We also house other advanced techniques like electron backscatter diffraction for crystallography. So kanina may presentation about microstructure. Our laboratory is equipped with all those instruments necessary for analysis of microstructural like alloys. So these are the lab in our Muntinlupa facility. And why is surface chemistry important? Because surfaces are, where corrosion happens. Surface is where adhesion takes place, or if you don't have adhesion, then this is surface is responsible for that. Surface is where catalysis occurs. Surface is where mechanical parts are lubricated, where medical devices contacts the body, where electrical contacts are made, where the rubber meets the road, where thin layers like glass and paints, where semiconductor device operates, where sunlight contacts solar panels, where charges move around in battery. So surface is a very important part of an object. And even though they are important, we lack sufficient capability in the Philippines to deal with the surface. Most people are familiar with scanning electron microscope and accessories that's attached to it. Unfortunately, the only surface that the semiconductor, the scanning electron microscope gives are the secondary electron signal used for imaging. It comes from 10 nanometers from the surface. But when you want to analyze the chemistry of the surface, the typical instrument used is the EDX, which is an X-ray analysis technique, X-ray fluorescence. And fortunately, the X-ray coming from the sample is not really coming from the surface. It comes from several microns from the surface, and if you use a different source like X-ray, generating another X-ray, the signal may come from even up to millimeters from the bulk surface of the sample. So the SEM, which we most know, is not really a surface analysis machine when we're talking about chemistry or chemical analysis. Now, I'm showing you different tools and techniques that most of you are already familiar. Like probably you're familiar with XRF on the end part of the table. You're familiar with EDS. Meron ba tong laser pointer? Wala tong laser pointer? Laser pointer? Meron ba tong laser pointer? Ayun pala, no? So, XRF, and then you have EDS. And you see, EDS here is several microns. No? And XRF even goes beyond microns, even millimeter. But the tools that are necessary for surface analysis, let's say the first 3 nanometers, are typically AFM, TUFSIMS, first 3 nanometers, AES, XPS. Those are what the true surface analysis equipment. And my topic today is focusing on XPS, or X-ray photoelectron spectroscopy. And XPS is coming from within 10 nanometers from the surface, from 1 to 10 nanometers of the surface. How is surface analysis performed? Usually we stimulate the surface with either photons, light, X-ray, ions, or electrons. And once we excite them or stimulate the surface, we measure the energy or mass in response to the stimulation. And since we're dealing with a very, very low energy or very low mass, then we have to place the sample, or we have to do this operation under an ultra-high vacuum system. And in case we need to analyze deeper part, more than 10 nanometers or even more, then we need to do our depth profiling. Now, XPS, which is not present in the Philippines, which is already a standard, or standard instruments for surface analysis, is one of the strong or most important technique for surface. It is also known as electron spectroscopy for chemical analysis, or ESCA. This is how the photoelectron is generated. First, you need to supply an X-ray, and then it hits the surface of the sample. And if the energy is sufficient, we can eject the inner core electrons, or the core electrons. And these core electrons has a corresponding binding energy. And that is, and then you have your work functions of the instrument, and then this constant. So that binding energy is also related to the kinetic energy of the electrons. This is an overlaid XPS spectrum to the electronic structure of cadmium. So these peaks are representation of the photoelectrons that were ejected from each of these shells or orbitals. Now I'm going to introduce Phi Genesis, and this is a system that's fully automated, and it's also a high throughput system. Because we need a high throughput system, because in order to reach a very high vacuum condition, usually it takes 30 minutes, 20 to 30 minutes in the vacuuming process. And so inside the system, there's an intro chamber that parks multiple samples at the same time. And once the sample in the analysis chamber is complete, the sample in the intro chamber that's already parked can go directly to the analysis chamber. Also, it's very high sensitive. We can analyze a sample size from 5 microns up to more than 300 microns. So we can adjust the spot size of X-ray from 5 to 300 microns. And then we can accommodate a sample size as large as 80 millimeter. And we also have an options of putting a chromium X-ray source. The standard in XPS is aluminum X-ray source, but aluminum penetrates shallower from the sample surface, and oftentimes, like when we analyze quantum dots, we need to use a harder X-ray, which is chromium. So PHI is the manufacturer of the instrument. PHI is a spin-off company from University of Minnesota in 1969, and they are the first one who introduced OJ electron spectroscopy in the market. And in fact, they dominate the XPS market in the world with more than 85% market share. And they partnered with Ulvac PHI, and in 2003, Ulvac is one of the biggest manufacturer of vacuum system, and they partnered with PHI, and eventually they acquired Physical Electronics, creating the company Ulvac PHI. And so they have a manufacturing facility in Japan and also in Minnesota. PHI or Ulvac PHI is the only supplier of surface analysis instrument that has a complete lineup from XPS, OJ, and ToughSIMS, and Dynamic SIMS. So this is a very nice graph showing the comparison of different analytical instruments from the smallest detection limit to the analytical spot size. So if we compare OJ, XPS, and ToughSIMS, among all these three, ToughSIMS can detect the lowest concentration, up to 1 to 2 parts per million. And in terms of sampling depth, 1 to 2 nanometers for ToughSIMS, and XPS, depending on the source, 1 to 10 nanometers, and if we use chromium, 3 to 30 nanometers, and AES is the same. In terms of detection limits, the superior is ToughSIMS, and the next is in the least in terms of detection limits between the three is AES, and somewhere in between is XPS. The strongest point of XPS is chemical state analysis other than elemental analysis. And in terms of quantification, XPS is has an excellent capability, while ToughSIMS requires standards. So typically, it's difficult to do quantification using ToughSIMS, and it's easy to do quantification using XPS. So these are comparison, and as I mentioned, Ulvac PHI has more than 85% market share and usually used by a lot of universities and also industries. And XPS today is not just XPS. It's considered to be a multi-technique. So we can, for example, attach a UPS or ultraviolet photoelectron spectroscopy and low energy inverse photo emission spectroscopy or LIBS and REALS. These three different techniques is used for analysis of for band gap analysis. No? So determining whether for semiconductors we need to determine the band gaps, and so these three different techniques are just an attachment to XPS. Also, we can now attach OJ. So you don't, for a start, you don't need to buy a separate OJ electron spectroscopy. You can just purchase an option and then attach it to the XPS. So this is how an XPS works. First, we need an electron source. And then these electrons bombards the anode, the metal anodes, and then it generates X-ray. And then these X-ray are raster scanned, and then these raster scanned X-ray hits the sample, and then the photoelectrons, the binding energy of that photoelectrons are measured by this high collection efficiency spectrometer. So XPS today is considered a multi-technique. So you can just attach, for example, you wanted to do a reals analysis for bandgap, for electronic structure, or you wanted to do a LIPES analysis for, again, electronic structure analysis. All you have to do is purchase that option and attach it to your XPS. And if you wanted to do an OJ electron spectroscopy, all you need to do is buy a separate Lab 6 electron gun and then perform the OJ electron spectroscopy analysis. So since OJ measures kinetic energy and XPS measures the binding energy, kinetic energy is related to binding energy by the equation I just shown. So even AES can already be performed using an XPS machine. So this is one of the strong points of these Ulbach Phi system is they're using a purely electrostatic lens. Unlike a system that uses magnetic coil will magnets or magnetic coil will interfere with the very low energy electrons, and the purely electrostatic lens will give us a capability to accurately measure the binding energy of even the lightest electrons. And another important technology of Ulbach Phi is that their X-ray can be raster scanned to generate an image called secondary X-ray generated secondary electrons. These X-ray generated secondary electrons is used for navigating your sample. Say you wanted to analyze a specific point in your sample, the X-ray can be used. So like in this one, this is XPS spectra of different points in your image. So this is your SXI or secondary electron generated image. And then all you have to do is with a click of a mouse, you just point the interested area to generate this XPS spectra. The most common practice in XPS is they're using an optical camera for doing the navigation. The disadvantage of using an optical camera is that, number one, you don't know whether you're exactly analyzing the specific point. But using an X-ray, an SXI image or electron-generated image then we can pinpoint exactly the point you wanted to analyze using XPS. Okay, so strong point is we are using SXI or X-ray generated secondary electrons for navigation. And with this, we can analyze very fast. We can get less than 10 seconds. We can get the spectrum, XPS spectrum. And this is an actual image in which if you use an ordinary optical microscope or optical camera, you won't see these particular contaminations in this polymer. But using an SXI image, we're able to image this particular contamination and just point it using the mouse, and we're able to identify the chemistry of these contaminants. Another feature of Ulbach Phi system is that it has an HAXPES mode, meaning that instead of using an aluminum anode, we just use a chromium anode as an option. So if you look at these comparison, this is an image using an aluminum anode, and this is an image using a chromium anode. So chromium has an energy of 5.4 keV, while aluminum has an energy of 1.4 keV. So chromium is more penetrating than aluminum. So if you wanted to analyze some layers of metals, or if you wanted to analyze quantum dots, which is a metal particles, then you need, oftentimes the use of hard X-ray is more beneficial than aluminum X-ray. So if we compare HAXPES, HAXPES has a spatial resolution of 15 microns, but aluminum or XPS has a spatial resolutions of 4 microns, and HAXPES has a sampling depth of 3 to 30 nanometers, while the XPS has a sampling depth of 1 to 10 nanometers. So this is an actual analysis of titanium chromium layer coated with yttrium oxide. And if you use an XPS, you won't see the clearly the oxidized layer after chromium. But once we use the hard X-ray, the chromium, then we are giving a more accurate analysis of the oxides that was formed between this yttrium oxide and chromium. And if we use HAXPES, usually in XPS we can tilt the angle. So that's what we call angle-dependent analysis technique. And once you change the angle, you can make the X-ray interacts to different thickness level. So in here, we can control the interactions of X-ray with your surface. You can control it to 1 nanometer to up to 10 nanometers. And if you're using chromium, you can control it from around 3 nanometers down to 30 nanometers, just by tilting the sample. And in here, we have a sample data that if we tilt the sample by 90 degrees, this is takeoff angle, we are seeing the oxidation less. And if we tilt the sample by 30 degrees, we're seeing the ratio of CR5 and CR6 more clearly. So the system has a capability to change the angle of the stage so that we can, control the interactions of X-ray to our sample surface. So this is an illustration of quantum dots. If we use aluminum X-ray, we're just, limiting the interaction to the outside portion of your quantum dots. But if we use a chromium X-ray source, then we can penetrate through the core of the quantum dots. Another important capability of XPS, which is not available in EDS, is the chemical state imaging. Usually the elements are binded to another element. For example, this is a semiconductor device. This is a bonding pad, so I'm sure those familiar with the semiconductor are familiar with the construction. This is your bonding pad, and surrounding it are silicon oxide. So when you run it using EDS, all you see are silicon. But you don't know whether silicon is binded to oxygen or it's binded to nitrogen. But using the chemical state imaging of your XPS, it's clearly showing that these area are purely silicon oxide, but this part of your sample is silicon nitride, meaning silicon binded to nitrogen, and these one are silicide. So we know that aluminum is the material for bonding pad of semiconductor. So this is an aluminum silicide, or silicon binded to aluminum. So using the chemical state imaging of XPS, we can clearly distinguish different types of silicon. A silicon oxide, a silicon nitride, and aluminum silicon silicide. And we can, of course, quantify the presence of these different types of silicon. This is an analysis of dental implants. So it uses a 60 millimeter diameter platen, and we can place multiple units in the platen. So we placed 4 different dental implants, and we analyze these 4 different implants. And using the XSI, which is the secondary electron image using the X-ray, we're able to navigate the surface of the dental implants. And using a 20 micron, so I said that we can control the X-ray from 5 microns up to 300 microns. So this time we use a 20 micron X-ray, and we're seeing that we're concluding that anywhere in this dental implant, the concentration is the same. But when we change the X-ray to 10 microns, we are now seeing different elements that are no longer uniform across the surface of the dental implants. So this is how important a surface analysis technique is. Because if you run it using your known technique like EDS, you won't see any difference in the surface of the dental implants. Another technology of ULVAC-5 is the control of charging. So if you are already familiar with SEM, you know that it's quite challenging to do qualitative analysis, even quantitative analysis, using a charging with a charging sample. And it's the same with other surface analysis technique, but the solution here is this patented dual beam charge neutralization, where they use an argon gas and low energy electron source to neutralize the charging. And as a result, we're able to precisely or accurately measure the chemical concentrations of our surface. Okay, and another one is the what we call the angle-dependent thin film analysis. So when we say thin film, that's between a few nanometers up to 100 nanometers. So in semiconductor, there are a lot of thin film applications. You coat your sample with silicon nitride, or you coat it with another barrier metal, and you need to precisely measure the thickness of the thin film. You won't be able to accurately do that unless you use a cross-sectioning capability or FIB. But with an XPS, all you need to do is just tilt the sample and then do an XPS analysis. Okay. And another, if you want to analyze several microns more than the surface, the practice is to do a sputter depth profiling. And one of the technology is to continuously rotate your sample while doing the depth profiling. And we can also attach several types of gas. So let's say you wanted to analyze organic samples, then usually we attach a GAN cluster ions. Okay. And then one of the strong points of XPS is we can attach an AES. So you don't need to purchase an AES. All you need to do is purchase an XPS and then attach an electron beam source to do an AES analysis. Of course, we know that the advantage of electron is the quality of the image. So like in this example, this is your OJ image, and this is your XPS image. So this is just a X-ray induced secondary electrons. The image is not as nice as your electron image. But if you attach an electron source to do an OJ electron image, then you can complement your data, your XPS data. Okay. And the system has a fully integrated user interface. You say you wanted to analyze multiple samples, all you have to do is program it, take your break, and then when you return, you already have your XPS spectra. And you can attach other techniques like LIPES for measurements of band gaps and measurements of HOMO and LUMO. I don't know if you're still familiar with it. This is, HOMO is your highest occupied molecular orbitals, and your LUMO is your lowest unoccupied molecular orbital. And usually you measure it when your energy is decreased, that's HOMO, and LUMO is when your energy started to increase. And then the difference between that is your band gap. Band gap is very important for light emitting diodes now, because you need to determine how much energy is needed or released in order to produce light. Okay. And also for semiconductor applications, we need to measure band gaps. Like silicon has different band gaps, gallium nitride has different band gaps, silicon carbides for EVs have different band gaps. And this is done using UPS and LAPS. And other techniques are reels, which is also used for band gap analysis. So this is an example of the data using analysis of an organic light emitting diode. This is copper thiocyanine, tallocyanine. So this is a most common material used for organic light emitting diode. So in summary, Phi Genesis is an equipment that's used. It's fully automated system, high throughput. You can attach different techniques for different needs. And then we can go down to 5 microns and very fast. And we can also attach an X-ray source for Hackspec analysis. Okay, so thank you very much. If you are interested on about this equipment, then you just visit Sigmatech, www.sigmatech.com.ph. They have a booth downstairs, and this is our new location in Carmona, Cavite. As mentioned, we house several analytical instruments, and if you are interested to visit our facility, just contact us. Okay, thank you very much.
Thank you, Engineer Liana, for that compelling and informative presentation. We are enlightened with the technicalities of surface analysis and its advanced instruments, which can also be a significant material characterization method for failure analysis in the future. At this point, we will open the floor for a brief Q&A session. We invite Engineer Mayet DeMarco and Engineer Ansel Rom Mendoza to return to the stage and join Engineer Liana for a panel discussion. Due to the time constraints of the program, we'll be limiting the questions to 1 to 2 questions. May gusto po ba magtanong? You may approach our speakers naman mamaya if you have questions.
I want to address this to the second speaker, Engineer May. But first of all, thank you, Sem Kalaka, on behalf of the Triple M for your generous support and putting trust in the department to ensure that FA is doable. No? I have 2 questions. First would be, aside from the significant reduction of testing cost, were there any observations in the improvement of the performance, such as, nag-decrease po ba yung parang unplanned downtimes during the collaboration with the department? And second, what do you think are the existing challenges or gaps that need to be improved or addressed for the collaboration between industry and academe to be more productive?
So, good morning po ulit. So for the first question po, so kasi yung engagement nila last August 2025 is metallurgical analysis. So ito kasi is kasi yung plant kasi is aging plant na. So we're just trying to, yung metallurgical kasi, we're just trying to assess kung ano po yung status ng pipings or something. So yung sabi mo kasi na reduction of unplanned or something, hindi kasi siya makakapag contribute pa as of now kung sakali. But because of that testing na ginawa ni UP and analysis, so we now know na so ganito pa yung life ng pipe namin or something. So yung life cycle niya is nakinalaman namin. So yun yung tulong sa amin so that we will know what will be the preventive action para hindi magkaroon tayo ng catastrophic failure or something or unplanned outages. So yun yung naging benefits sa grupo noong ginawa nating metallurgical testing or yung NTT. So yun po. Yung isa.
So for the gap naman, siguro as of now, isa naming nakikita ang pwede pang improve is, yung nabanggit ko kanina is, aside from the analysis itself ng mga metals, I think important din na over the multiple engagements ng team UP sa amin is ma-encourage namin sila or ma-impart namin yung operational history ng planta namin. Because that operational history, yung mga operational data and statistics would support yung kanilang findings. So mas masasagot kung bakit kaya ganito yung findings dito sa specific metal na to, ano ba yung mga operational exposures na pinagdaanan niya, ilang years na ba siya in service. So more of yun yung kailangang i-build pa for the next engagements para mas maging concrete yung findings nila, mas relative dun sa operational history ng planta namin. And for the unplanned naman, dagdag ko lang dun kay Sir Ansel. So yung kasing ginagawang analysis ni UP Triple M sa amin, ginagamit namin yun as basis for our maintenance strategies. So while hindi pa natin makikita agad yung result, but definitely if in the long run, in the years wala kaming maging unplanned outages because of pipe ruptures or high energy piping incidents, that would prove or yun yung evidence na effective yung aming ginagawang maintenance strategies based on UP findings. Yan po.
So, question lang po kay Sir Marlon. Tama po wala pang XPS dito sa Pilipinas, sir? May na-foresee po ba tayo na meron po bang magkakaroon later on para maging accessible siya sa Philippines?
Actually, may mga projects, no? Pero I think nasa funding level pa, no? So may mga inquiries ng XPS. Pero I think, no, para sa akin, UP should be one of the, a very good candidate university for having this kind of instrument kasi madali kayong makakuha ng funding. And besides, you're one of the top university. Lalo na meron na tayong mga FA hub, and I think ito lang yung university other than yung na Mapua na medyo engaged sa semiconductor applications. Andyan si Doc Mena, which also a semiconductor practitioner for very long. So having an XPS, no, marami tayong magagawa. If you have like projects about battery, if you have projects about light emitting diodes or mga OLEDs, any of those materials, and if you have projects related to different semiconductor substrates like gallium nitride or silicon carbide, or not just silicon, then definitely having an XPS system would be useful, no, for accurately measuring the necessary band gaps to initiate the performance of the substrates.
All right, that wraps up our Q&A session. If you have more questions sa ating mga speakers, you may approach them after the session. Thank you. And now, we thank our audience for those engaging questions. To show our sincere appreciation for the invaluable insights and time shared by our speakers, we would now like to present them with these tokens of gratitude. May we please invite to the stage Sir Stan and Doc Mitch to present the tokens of appreciation.
So we award this certificate of appreciation to Engineer Mayet Di Marco, similarly with Engineer Ansel Mendoza and Engineer Marlon Gana. Okay, so for their invaluable contribution as plenary speaker in the Interface 2026, okay, held this day at Triple M Department, University of the Philippines, Diliman.
So again, we thank you, our second batch of plenary speakers, for your meaningful talks for this morning. So at this point, we shall now adjourn for a luncheon at the floor room. We request our esteemed guests to return by 1 p.m. as we resume our technical discourse, and kindly coordinate with our staff to present your meal stubs for your provided lunch.
So while on break, we encourage you to view the undergraduate research showcased in the poster presentation and smoking gun exhibit in this well room. Your participation is also crucial in the selection of the smoking gun exhibit winner for the People's Choice Award. So please, i-remind ko lang everyone to please vote for your favorite entry via the QR codes na nakapost sa ating auditorium as well as dun sa exhibit area. Thank you!